Hello, 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 folks. How we doing? We're gonna get started here in about 1 minute. Good to see everybody here on this lovely Sunday. Hey, Ahmed, how's it going? I hope you're having a good day so far, Ahmed. It's a little bit rainy and gloomy where I am today, but that's not a bad thing. The plants like the rain. I hope everybody had a good week this week. Well, I guess the last 2 weeks since since I didn't stream last weekend, but yeah, my day is going well, Ahmed. Thank you. Ahmed says I started React last week. It's amazing. Oh, that's awesome, Ahmed. I'm glad you like React so far. Alrighty. Well, folks, the timer has counted down, so we're going to go ahead and get started. I'm going to give folks a little bit longer to get in here today since I was a little bit late on starting the countdown timer. So that's on me. Uh, but yeah, Ahmed, I'm glad you're liking React so far. This is actually part 8 of an ongoing React series where we're going through the official docs. So welcome, everybody. If you're new to this series, it is beginner friendly. We're just going through the official documentation. We're doing the examples. We're doing the challenges. We're taking our time and going through each section. However, we are pretty far, through the documentation already, so it will be helpful for you to follow along. If you'd like to follow along with us, it'll be helpful if you have something of a previous knowledge of state, props, and components, how they work, what they are, what they're for. But of course, anyone is welcome to come in and hang out. You don't necessarily have to follow along. You can just chill with us in chat if you would like to do so. But yeah, we're gonna give folks a little bit longer to pop in. Um, so yeah, I hope everybody had a good week. I will admit, I'm a little tired today. I had a family thing last week, and I had to drive like 6 hours to get there. And I really wish that the United States had proper, public transportation infrastructure, um, because I don't like to drive that long. But we don't have proper trains and buses, so driving is the only way to go. But we'll get there someday. I hope so. Either that, or I'll just move to Europe. Move to Europe where I can ride a train and nap. We're on my way to my destination. But yeah, a little bit tired today, but I always find that streaming helps give me energy. So that's the main benefit for me, is that it does perk me up. So I'm hoping that happens. Ahmed says, I haven't touched state yet, but getting there. Well, that's awesome, Ahmed. They say, how is your kitten? Have you given her a name yet? I actually have 3 kittens. They are foster kittens. They are so my local animal shelter, I do fostering with them. So they aren't strictly mine, but I get to raise them and name them. So those kittens will be making appearances throughout the stream today. Generally, the way I do it is after breaks, I kick my dog out of the room, and the kittens, I bring the kittens in because my dog is a little bit too interested in small animals, so they can't share a space. But generally, after breaks, dog goes out, kittens come in, and we get a little bit of FaceTime on camera with the kittens. So that should be fun. And as far as what we're talking about today on stream here, we're going to be talking about extracting state logic into a reducer. So, reducers are a new concept. So, real quick, we're just going to. Oh, I got to turn on closed captions. My automatic captioner just reminded me to do so. One moment. Give me just a moment to do that. I do have closed captions for folks that want or need them. As soon as I turn them on, of course. That's the hard part, to remember to turn them on. So I'm going to go ahead and connect and Captions should appear momentarily. There we go. Captions are on. If you'd like to turn on closed captions, you can hover your mouse over the right side of the stream window, and a little pop-up should appear with the closed captions symbol. And you can click that to enable or disable closed captions. All right, so we are introducing the new concept of context and reducers today. Hey, no worries, Night Brit. Night Brighto Mart. Sorry, yes, good. It's working great. Yeah, no worries. Welcome to the stream night. Glad to have you here and everybody else. Glad the captions are working. So yes, today we're introducing reducers and context. Real quick, it's been a couple weeks since we last saw each other. So last week we talked about, or sorry, 2 weeks ago we talked about preserving and resetting state. So real quick recap there. Basically, with preserving and resetting state, what we learned, and I'll just go down to the recap here. What we learned was that React keeps state in place. So by state, what we mean by state is basically the characteristics of the appearance of that component, right? So certain things that control the behavior and appearance of a particular component are stored in what we call state, right? That's the state. And that state can be changed if we want to change the appearance of that component. However, React keeps state in place for as long as the same component is rendered at the same position. And so what we mean by position is the position of that component in the UI tree. Now, you may be already familiar with the concept of the UI tree. When we think about the DOM, does anybody not know what the DOM is? Or can anybody explain what we mean by DOM? If you're familiar with HTML, you should be familiar with the DOM and what it's for. Hey, Chris, how's it going? Good to see you. Hope you're having a good day. What is the DOM? Yeah, Dev Limiter says document object model. Absolutely. So and it's basically yeah, and actually yeah, the DOM. Yeah, fantastic answers from everyone here. So Knight says the DOM renders the code. Dev says it's an object representation of your HTML. It's a tree, and Ahmed says it's a tree structure of your whole document, like HTML elements. Exactly. It's basically how the browser creates a hierarchy of your HTML, and that's what that's how it's displayed in the browser. And so React has something similar, and it's the UI tree. So when we talk about position of where a component is located, we're talking about that position in the UI tree. And that's how React determines which component, if any, to assign a state value to, right? So state and components are two separate things, but React matches them up by looking at a particular component and its position in the UI tree. So, and as they say here, state is not kept in JSX tags. It's associated with the tree position in which you put that JSX. So that's how the pairing is made between a component and its state. So if we remove a component from its existing position, even if we keep that component, if it moves somewhere else, React no longer matches that component because it's not in the same position. So the state is reset. And sometimes that might be something that we want, right? Sometimes we don't want to store state between renders. So we just move a component and demolish the state. However, sometimes we want to preserve state and make sure that state is not wiped out. And we looked at several examples of that. If you want to see examples of when we might want to versus might not want to preserve state, I would suggest looking at the examples in this section. But one way that we can preserve state is by replacing a component with an identical component tag in the same position. So that component might be different, but if it's, let's say we replace an H1 with an H1, with a different H1 in the same position in the UI tree, then React can assign that state to that component as well, because it's the same tag in the same position in the UI tree. However, we can force a subtree to reset its state by giving it a different key. So if we want to force a reset, we can simply give it a different key. Now we know what keys are by previously looking at lists in React, right? We've looked at lists before, and lists are a little bit different in React than they are in HTML, right? Because in React, React needs to know when a list item has changed. It needs to explicitly know which items have changed and which have not in order to know which parts of that list to re-render. So React requires us to give keys to each item in a list. And so we can use that capability, the fact that React understands and recognizes keys, we can use that capability to force a reset of state by giving a component a different key. And also then just a warning of don't nest component definitions or you'll reset state by accident. We already know that when we're defining components, we aren't supposed to nest them. And this is just another reason why we don't want to accidentally reset state when we're not expecting to do so. Okay, so that was my, very quick recap, 5-minute recap of what we spent our entire stream 2 weeks ago talking about. So just a quick refresher on what we talked about, and in particular, sort of reminding ourselves of the UI tree and what that's for, and that it exists, that React recognizes it, because we're going to sort of leverage that tree in some of the things we're going to be talking about today when we talk about reducers and context. So does anybody have any questions about what we talked about last time before we go on to the new stuff? Thanks, Chris. Always Wolfie fam, indeed. Does anybody have any general questions? And also, as always, if you're new to the stream, feel free to ask questions at any time. I'm very open to questions, and you're not. Don't worry about interrupting me or anything like that. I always keep an eye on chat, and I will answer your question when I am able to do so. Okay. Well, ask anytime. Oh, before we get started, one last thing. I want to thank Yu Hua, and I'll see if I can replay their sub here. There we go. I have a new capability. I can replay notifications if they don't display. So, Yuhua subscribed in between streams. They thought I wouldn't notice, but I did. So, thank you, Yuhua, for the sub, the Prime sub, which didn't cost them anything, which is why I love Prime subs. All right. Well, let's go ahead and get started. So today we're going to be talking about hopefully both reducers and context, because the very last little chapter of this section of the docs is about using reducers and context together. So I would really love to get through all 3 of these today. That's ambitious. We'll see if we can. But I'm sure y'all will be along for the ride. So, all righty. Here we go. So first thing we're going to talk about today is reducers. Again, reducers are a new concept. They're not something we've looked at before. But here, in both reducers and context, we're going to start to talk about some of the things that might become challenging when you start building larger or more complex apps with incorporating state, right? Because state is a wonderful tool, but it could get complex really quickly when you have multiple instances of updating the same state, when you start to nest things very deeply and have to pass props down through multiple components. And so React has a few different ways that we can reduce that complexity, one of them being a reducer, and make things easier to work with. Tenor 7 says, Tenor 12 says, I'm using use context with Firebase off right now. There you go. See? Yeah, real life applications. That's great. Fuel Snapple says, reduces my understanding. Well, hopefully it might be a little bit easier to understand after we talk about it today. That's why we do these things, right? That's why we go through it together. We take our time, we go at our own pace, and we just get through the material. That doesn't mean you have to understand it right away, but it just exposes you to it, and we do some examples. Zena says, happy Sunday. Oh, happy Sunday to you too, Zena. I hope you're having a good day. I'm having a better day now that I'm on stream. I'll tell you that. All right, so let's talk about extracting state logic into a reducer. So components with many state updates spread across many event handlers can get overwhelming. For those cases, you can consolidate all the state update logic outside your component into a single function called a reducer. So real quick, just as a reminder, we update state using, the using basically using a set function, right? We have to call a specific function in order to update state. We can't just take our state variable and change it to something else, right? We have to call a set function in order to do that. And event handlers, what those allow us to do is take in user interactions of some kind. So a click, a scroll, a key press, that kind of thing. We can use event handlers to capture that and trigger a state update, right? So sometimes we might have a lot of different ways that users can interact and trigger a state update, right? Maybe a click, a scroll, and a button press all change the appearance of our layout in some way. Maybe they make a menu bar go away, or maybe they change to a different animation, right? And so we need to consolidate those. If we have a lot of them, they can get overwhelming really fast. And so reducers can help us consolidate those. Fuel says, is React Signal something you will cover? Basically, we're just covering whatever, for now anyway, we're covering whatever's in the official docs. So feel free to read ahead. It might be in the escape hatches section. You could look in there and see if that's something we're going to cover. We're not covering it today. Ishogo says, hey guys, I got an interview and a take home. Good job, Ishogo. Or Isihogo, sorry. Good job. What's the position for? And if you want to follow along in the docs as well, I'll put a link in chat. Full stack position. That's exciting. Good job. Tenor says, docs aren't clear to me. That's all right. We're going to talk through it. Hopefully it'll be a little bit more clear after we talk about it. He says, I had to learn Svelte and GraphQL for the take home. Oh yeah, I did a little bit with GraphQL. It's interesting. All right, so let's talk about it. Today we're going to learn what a reducer function is, how to refactor use state to use reducer, when to use reducer, and how to write a good one. Good job, Izzy. You finished it. Great work. So as components grow in complexity, it can get harder to see at a glance all the different ways in which a component's state gets updated. So let's look at an example of when that might happen. This task app component below holds an array of tasks in state and uses 3 different event handlers to add, remove, and edit tasks. All right, so let's look at that, what's happening here. And we can kind of see, right? There's 3 different ways that we can interact with these tasks. We can add tasks, we can, edit them, we can delete them, right? And those are all different ways that we can trigger a state update. And we know that state is being updated, right? Because the appearance of our component changes. And that is, by default, basically the definition of state. However, let's go ahead and confirm that. Let's confirm that we have 3 different ways that we can interact with the current state or appearance of this component. Gil Neville says, GraphQL, my old enemy. All right. So here's the first one. We can see this interaction, right? Set tasks is here. And what it's doing is it's adding a task. So what we're doing here is we're updating state, taking the current list of tasks and adding a new one. So that makes sense. That's one way that state is being updated. And here we have another one. Handle change task is also calling set tasks, which is our update state function. And it's finding the task that already exists and applying our update to it. So whatever the user has entered, the text they put in the input box, it's going to apply that to the task. And then finally, delete task does what it says on the tin, and it filters out whatever task ID we pass into it, right? Take that and look for the task that matches that task ID that we pass into it and delete it. And Down here, we're also, applying those event handlers. So handle change task, handle delete task, and then above, handle add task. So those are our event handlers. So yeah, like they said, three different ways to interact with this task list. And but if we look at it, they're all calling set tasks, right? So they're all essentially calling the same update function, but just in three separate places. So a little bit repetitive, could be a little bit confusing. Imagine if we had three other additional ways to interact with this list, right? That could get real confusing if we're calling set tasks in like, six different locations. So there has to be a better way, right? Best infomercial voice. There must be a better way. And that better way is reducers. Oh, Jetsuko, thank you for the sub. That totally didn't appear on my notification list, but I see you here. Thank you, Jetsuko. I very much appreciate the sub. Let me see if I can. I'm gonna. Can I pin that? There we go. Because my notification didn't pop up, I went ahead and pinned your message to the top of the chat. So thank you, Jetsuko. It's my cheap replacement for that notification not working. All right. So each of the event handlers that we talked about calls set tasks in order to update our state. But as the component grows, so does the amount of state logic sprinkled throughout it. To reduce the complexity and keep all the logic in one easy to access place, you can move that state logic into a single function outside the component called a reducer. And reducers are a different way to handle state. You can migrate from use state to use reducer in 3 steps. So we move from setting state to dispatching actions. We write a reducer function to hold the actual updates, and then we use the reducer from the component. Now that sounds like complete garbage right now, makes no sense, but we're going to talk through each of those steps. Third Decade says reduce set tasks down. Yeah, essentially that's what we're doing. We're reducing the amount of set task actions that we have to have sprinkled throughout various locations, right? We're consolidating, we're reducing things down into a single location. So step 1 is move from setting state to dispatching actions. And the way we currently have it set up and the way we've learned how to do things so far is to create an event handler, right? And then essentially immediately call our update function, right? Somebody clicks a button and that triggers an event handler. And then inside of that event handler, we immediately trigger a state update. That's how we've done things so far. We can see that here. However, what we want to do instead is remove all of the state setting logic and take it down to still having the event handlers to listen for user actions. Just call handle add task, change, and delete. And what we're going to do instead of immediately updating state inside of those is essentially we're going to turn those event handlers into messengers, right? Into couriers that are going to carry a message to our reducer to tell it to update state. So managing state with reducers is slightly different from directly setting it. Instead of telling React what to do by setting state, you specify what the user just did by dispatching actions from your event handlers. So what does that mean? It's sort of like, so think about like a really small office, right? So in a really small office, you might be sitting next to your boss, like in the next cubicle, right? You might be sitting right next to your boss's desk. And if your boss wants you to do something, they can just stand up and tell you directly, right? They can just like be like, hey, I need you to, do your TPS reports or whatever. Get some paper off the printer. I don't know. I haven't worked in an office in 3 years. It's a little foreign now. But so they might tell you, directly what to do. However, let's say your office gets really big and now your manager is like has direct reports that are all over the building. The physical proximity is no longer there, and your manager has three direct reports in all different places. Now, if we were back in like the 1950s, right, what your manager might do is write a message down on a piece of paper for each of their direct reports. They would write a memo, right? They used to have these things called memos, the interoffice memos, and they would put them in envelopes. And you would give it to a courier or a mail person, a mail carrier. And that mail carrier or courier would deliver that message to the direct reports individually because the office is just too big to tell them directly, right? It no longer makes sense for the boss to walk directly to the desk. Instead, they dispatch a message to the direct report to tell them to do the thing. So that's essentially what we're doing here. Our apps have gotten larger and more complex. Calling set actions in multiple locations is no longer feasible. And so what we want to do instead is dispatch a message to another location to do the update there. So that's it. And we're going to see how to do that. We're going to literally call something called dispatch to send a message from our event handler. So our event handler becomes that courier that's going to carry that message somewhere else. Hey, Madeline. They say, can't stick around, but I like to name my kitten Madeline. If I get to name, yes, you absolutely do get to name a kitten Madeline. Madeline claimed a channel points reward a long time ago to name a kitten. And so they get to name one whatever they want, as long as it's work appropriate. And Madeline is absolutely work appropriate. Madeline, if you want to stick around, if you're able to stick around until the first break, that's when I'll be showing a kitten on stream, and you can name that kitten. If you're not able to stick around, let me know, and I will maybe we can maybe do a call another time, and I can show you your kitten live, because I'd like to see your kitten live. TPS reports indeed. Yeah. Fuel says, now I remember the scene from the movie Brazil where he breaks the messaging system. Yeah, it's like those pneumatic tubes, right? Like you get at the bank. Yeah. All right, so that's what we're doing. We're sending messages elsewhere. So instead of setting tasks via an event handler directly, you're dispatching an add, change, delete task action. And this is more descriptive of the user's intent. All right, so now this is what our event handlers become. So for add task, we send a dispatch. And it's so much like, if you think about like a telegram, it's literally like that. All we're doing is we are dispatching a literal message. This is just an object. We are dispatching an object containing the information that our reducer needs to know. It doesn't do anything. It's just a literal object containing some information about the action that we want it to perform. It's the boss telling the coworker, telling the subordinate, do this. And we send that message with our dispatch courier to go to our reducer. That's all it is. And we can see that's what's happening here, right? First one, we have a type added telling, okay, what am I supposed to do? I'm supposed to add a task, add something. The ID that we want to attach to that task, and then the text that we want to put in the task. That's all the subordinate needs to know. Same with change, right? What's happened? Oh, we've changed something. Okay. Which task changed? That task. And then delete, same thing. What happened? Oh, we want to get rid of something. Which task? That task. Okay. And then the object that we pass to our dispatch is literally called an action. It's the message, the thing that we want to happen. And it's just an object. Okay. You decide what to put in that object. There's not any requirements. It's just whatever your reducer is going to read in. It should contain the minimal information about what happened. And so we're going to add the thing that's going to read that dispatch in a later step. But for now, we're just setting up the message, right, that we want to send. Okay. And again, this is just a JavaScript object, right? It is nothing special. An object can have any shape, but by convention, it's common to give it a string type that describes what happened So added, changed, deleted, etc. And then pass any additional information in other fields. So the type is specific to a component. So in this example, either added or added task would be fine. Choose a name that says what happened. Okay? So here's what happened, and then any other information that the destination needs to know. So step two is then it's basically now we're setting up the subordinate. We're setting up the worker that's actually going to do the work that the boss wants us to do, right? So in this sense, the user is the boss. They click a button, they trigger an event handler. The event handler is the courier, which carries the message. And then the reducer function is the subordinate that actually does all the work to update the state. So our reducer function is where we put our state logic. It takes two arguments, the current state and the action object, and it returns the next state, whatever that next state is. So this is the general format of a reducer. Function, your reducer, takes in the current state and then whatever we want to happen. So React will set the state to what you return from the reducer. To move your state setting logic from your event handlers to a reducer function in this example, you declare the current state as the first argument, declare the action object as the second argument, and return the next state from the reducer. And then React will do that update. So let's see how that looks in the context of our basically our task app that we've been working with so far, right? We take in the current state, which is all the tasks that currently exist, and then whatever we want to happen. So remember, action is an object, right? It contains several things. So if action.type is added, so we go into the action object and we grab the type of action that's being performed. So we can see that that's the determiner here, right? We have an if statement that's looking at the three different types and then just performing whatever action needs to be performed, right? We've done stuff like this before. It's a pretty standard if-else statement. It's looking inside of the message that we're sending and it's saying, all right, what's supposed to be happening here? Okay, adding a new task. Cool. I'm going to take the current state and I'm just going to append the new task to it, right? And then if it's changed, it's going to do all the things that it was doing before, essentially in those individual set state statements, right? It was doing all these things. We've just consolidated them together in a single location. And we use the contents of the message that we're sending in order to figure out which action we should perform. Okay? Now, is this tracking so far? Is this making sense? You know, we're taking all these disparate state updates from all these different locations that are really hard to keep track of. We're bundling them together into a single location, and then we're just sending messages to tell this reducer exactly what to do with a given message. And those messages are sent by our event handlers, which are triggered by user interactions such as a button click. So I hope you can see the connection between what the user is doing, what message gets sent, and what update gets triggered. So feel free to ask if you don't understand. There's no stupid questions or simple questions or anything like that. Feel free to ask. Makes sense so far? Okay, good. Does tasks reducer get called at all? Well, let's see about that as we get a little bit farther down. But yeah, I think we'll see in a minute how it all kind of fits together in order to trigger that. But hopefully what we've seen so far is making sense. All right. Because the reducer function takes our state as an argument, you can declare it outside of your component. This decreases the indentation level and makes your code easier to read. So essentially all they're saying here is that we can pass state into our reducer as an argument and it can use it. And if you want to, instead of if else, all this note is saying is that you can use switch statements instead. Switch statements are my beloved. I love switch statements, but most people don't. So really, whichever you prefer. You can use is if else for a long string of options such as this. They do say it's convention to use switch statements inside reducers. Um, but if you want to use if else, I mean, it's JavaScript, right? Who's going to stop you? You can do JavaScript lets you do whatever the heck you want at any given point. So convention means nothing. Be a trendsetter. Do whatever you want. And they also recommend wrapping each case block um, into the curly braces so that variables declared inside of different cases don't class with each other. And then you should always end your case statements with a return. We should know that already, but don't let your code fall through to the next case, which is the major pitfall of switch statements. And then, but they say down here, if you're not comfortable with switch statements, use if else. It doesn't matter. That's why I love JavaScript. Okay. So now we're going to I think the next thing we're going to answer here is what Zena asked about using Task Reducer. How do we hook up Task Reducer into our component, right? And Feels Neville says, we are developers. We can spend hours fighting over minuscule topics. Absolutely. I see that happen a lot, right? And I think that's one of the things that can be a major turnoff for people who are new, right? For people who are just getting into the tech world, because they think that things are super important and they have to be done a particular way. But when you're learning, man, just mess around, write bad code, right? Like just slam it out, make it work. And then once you get it working, then you can refine it and refactor it as much as you want, right? But just build cool stuff. Doesn't matter. Just do it. Like Nike, just do it. Or Shia LaBeouf, whatever. Okay, so real quick, I just want to look at this deep dive here. I think I missed this the first time I was going around. Oh, yeah. Basically, just this is a little bit, I did look at this before, but it says why are reducers called this way, but it's essentially why are reducers called reducers? And I kind of made the connection earlier that reducers are called that way because they reduce the amount of separate state calls that we have to make, but actually they're named after the reduce array operation, which okay, but essentially reduce operation lets you take an array and accumulate a single value out of many, and so that's kind of what a reducer function is doing. Yeah, so that's really all it's saying. I'm not going to spend time on that, but that it's just saying that's why reducers are called reducers. Devil Marie says, yes, the reduce method. Yeah, it's a very useful array method. And if you're not familiar with that array method, I would suggest learning it. Reduce can be super useful to help you aggregate things in an array. Crispy says, Mayan merch idea, just do it or whatever. Yeah. Just do the thing. I don't care. Just do it. Does it work? Great. Do it. I ain't a stickler. All right. So to answer Zena's question from earlier, how do we hook up Task Reducer to our component? Well, the first thing we need to do is call an import, right? We're incorporating a new, we're incorporating sort of some new React functionality, right? And so whenever we do that, whenever we incorporate state, or whenever we bring in a component from an outside file, right? Anytime we're bringing in something new that's pre-built from the outside, just in a very general sense, anytime we bring in something new that we did not build ourselves from the outside, whether it's an extra file or the React library itself, we need to call import, right? And I think that's the probably the thing that people forget most commonly, right? Is that you have to call import anytime you're bringing in anything from the outside. And so we do it here. We're going to import use reducer from React. Tender says, so reducer is used for putting together a bunch of states and functions. Yeah, essentially we're consolidating. We're consolidating our state updates into a single function. Yeah, that's what we're doing here. And we're importing the ability to recognize that reducer from React itself. So that's what the import is for. The ability to recognize that we are going to dispatch messages to an external reducer. And basically just the ability to enable that functionality requires us to import use reducer. And we'll see how that gets applied in just a second. So now, instead of calling use state, which is how we've normally set up state, right? We've talked about this before. When you first initialize your state, you set it up like this. We set up our state variable, we set up our update function, set tasks, and then we set the initial value of our state using use state. Okay. We replace that with use reducer. So now look at the difference. We still have our state variable, which is tasks, but now we're telling React that instead of updating our state immediately from an event handler, like a user clicks a button, we immediately update state within that event handler. Instead, we want to outsource that, right? We're saying, no, I'm not going to do that right away. I'm going to send a message. I'm going to send a message to my reducer using the event handler instead. I'm adding a courier. I'm adding a middleman. And so we got to tell React that we're adding that middleman. We're adding our dispatcher. I'm hiring a messenger, this dispatcher, to send the messages instead. So that's what's happening instead. So now use reducer takes our state variable and then the fact that we're using these messengers, and then we call use reducer and we pass in our reducer function. So Zena, that answers your question. We pass in our reducer function and the initial state value. So essentially, we're pre-notifying React, and we're saying, hey, React, whenever we have an event handler, I'm actually just going to write down a message for you, and we're going to have that event handler deliver it, but you need to know that the address that we're delivering these messages to, right? Like React needs to know where these messages go. Where should I send them? I'm going to send them here to this reducer function that contains all those state updates. But just because we're declaring state, we also need to then also have the initial state value. So that's something we always need to include. But this is the new element here, which is our reducer. And the fact that we're telling React we're using those messengers to send messages to our reducer. Okay, thank you for the follow, Brazzy W. Thank you. Okay, so that was kind of a lot, but we're going to walk through how all this works together. But feel free to ask questions if it's still not, clicking. And this is another hook, right? It's a hook just like use state was a hook. And we must pass an initial state, and what it returns is a stateful value and a way to set state. In this case, the dispatch function, but it's a little different. So use reducer takes two arguments: the function itself, task reducer, the destination for our messages, and the initial state, which we need to have anyway if we're declaring state. What it returns then is the new state value itself, which is stored in tasks, and it sets up our dispatcher to send messages to our reducer. Oh, thank you for the follow. Hello, Elio. Deb says, it's making sense to me, but I'm still not sure I see the benefit. Yeah, and they're going to talk about that a little bit later. You don't always need to use reducers, but they can be helpful, and you should probably know what they are and how to use them if you need them. Okay, so let's look at the full thing wired up and kind of walk through it a little bit. So we have our initial tasks right here, and they're stored in an array with 3 objects inside of it. Cool. And we also have a next ID value, which basically just says this is the next value that's going to be set when we add a new task. Our next value is going to be 3 because we have 0, 1, and 2. So next value is 3. Now, let's see, where is it? Sorry. So now we're passing into our task list our event handlers, same as before, right? So let's say that, well, let's look at add. So let's say I type in something new here and I click add. I'll thank you for the follow for you, Honik. Thank you for the follow. Code Zulu says, did I miss the kitten show? No. About 15 minutes, we're going to take a break. And then after that, we will have kitten time. So just stick around a little bit longer. All right. So when I click add, it's going to call this event listener, or sorry, event handler, add task. All right. So let's find that and see what happens when we do. Handle add task is going to take in whatever text I typed into the box. It's going to take that in. It's going to build an object that says, hey, this is what happened. Somebody added a task. This is the ID that you're going to assign to that next task. So it's whatever, next ID plus plus. And then the text is whatever text was entered. Now, this is all our reducer is going to need to know in order to update state and then, trigger a re-render here. So we've built our object, and our dispatcher is going to bundle up that message and send it to the reducer. Now, our dispatcher knows where to send that message because when we declared state, we set the destination location already. So React knows where to send it, and so it's going to send it to our reducer. All right, so the reducer then takes in the current list of tasks and then whatever action we said. So that's going to be essentially the message. It's taking in the current list of tasks and the message. So first one here, it looks and says, oh, action.type. What is our action.type? Action.type is added. All right, so we go into our first switch case here, and it says, okay, I'm going to go ahead and return the current list of tasks, and then I'm going to append the ID that we passed in the message, the text that we entered for the message, and then, a false value for done, which is basically whether it's checked or not. So by default, it's going to have a false value for done. So what that does is it gets sent back out of the reducer as a new state value, right? This is now the current state. It's the current list of tasks plus the new one. And then every time we update state, right? Every time we set state, we trigger a re-render. And so it adds the new task to the list. And if we want to see, we want to see how that looks. I keep scrolling weird. That's all right. Well, if we want to see how that looks, essentially what it's doing is then it's, re-rendering all these components here. And we don't actually have the code for task list. They don't show us that. But all it's doing is just triggering a re-render with the full list of tasks and the new one at the end. So does that make sense how that works then? I'm not saying that you need to be able to write it out right now, but conceptually, does it make sense how we walk through that? I'm happy to walk through another example if you want to see another example, like another, path. Code Zulu says, I'm on episode 2 of the series, but I came just for the kittens. Hey, that's fair. I'm not offended. That's valid. All right. Makes sense so far? Okay, good stuff. But if it doesn't, that's okay. You're allowed to say. And then you can even move your reducer. Oh, you want to do another? Okay, Champo and Tenor want to do another. That's perfectly fine. So let's walk through a different path. All right. Got some weird scrolling going on. I apologize if it jumps around a little bit. It keeps scrolling weird. All right, so let's look at another one. We looked at the add path before. Let's look at the edit. So I'm going to go ahead and edit this Kafka museum. path here. On Tuesday. I'm just going to say that. And I'm going to click save. Okay. And so obviously, when I do that update and I click save, on the re-render of the component, we see the updated message. Okay. So how does that work? How did we do that? Well, when I'm interacting with these buttons, what I'm actually doing is I'm triggering an event handler. We have these event handlers that are listening for user interactions and then doing stuff based on those interactions, right? That's what event handlers are for. They listen. They listen. They're the Smurfs of the React world. They listen for the user to do something, and then they capture that, whatever the user has done, they capture it, and then they make React do something with it. So what happened? Well, the event handler that's triggered by the edit button is handle change task. Okay, so that's what gets triggered by it when we click the edit button. So handle change task takes in information about the task that was changed. It takes that in and it builds the message, right? It builds our event handler here is our messenger. And so what does it do? It writes a message containing certain information that our reducer needs to know in order to actually update the state elsewhere. So the first thing it does is it sets up our dispatch. It sets up our message. And that message is literally just a JavaScript object. It's nothing special. It is just an object with various characteristics that the reducer needs to know in order to do its job. Okay, so this dispatch has two things inside of it. Type, what is happening, right? In order to do its job, the reducer needs to know what action it's supposed to perform. So, all right, something has changed. So the reducer can say, oh, okay, I'm going to need to change something. And then information about the task that was changed. That's all that the reducer needs. Tender says, so the reducer is kind of like an on change. Well, the reducer is basically just like a hub. That all that hub does is set state. That's all it does. It just does various types of setting state. However, in order to know exactly how to change state, what types of changes it should be making to our state, is it adding, is it deleting, is it changing an existing value? What is it supposed to do? It needs some instructions. And so the first thing that we do is we use our event handler to build those instructions. Okay? So this dispatch gets dispatched, the message goes out, and it goes straight to our reducer. Our reducer is down here, and it takes in whatever the current state is, right? So here's what we're working with. This is what we have right now. And then whatever message we send, right? So just like a real worker at a real job, they start out with something, and then they get some instructions, and then they turn it into something else, right? And that's all the reducer is doing. So we have the raw material, we have the instructions on what we're supposed to do, and then we go into our switch statement to determine exactly what the output is going to look like. All right, so we go into this object, this message that we sent, and we said, all right, what is the type? So in this case, type is changed. So we go into our switch statement. First case is added. That's not right. That's not what we're doing here. Okay. Next case, changed. Aha, this matches. I'm going to do this. Our reducer says, all right, this is what I need to do. This is what the instructions say. And all that we're doing here, this looks a little bit complicated, but all we're doing here is we're just looking in the list of existing tasks, right? Because this is a change. So we're looking in the list of existing tasks, and we're setting the value of that task. So that whatever the text is, we're setting that to whatever we pass through in the message. So in this case, I passed in this message here. This is my updated text, visit Kafka Museum on Tuesday. And so it just does that update, and it sets that as the new state. Uh, Tenor says, okay, it's the setter. Yeah. Tenor says the type is the clarifying attribute of what we're going to do. What are the types we can do? Anything you want. You control this, right? You write your reducer. Whatever you need to do. It might be add, change, delete. It could be, I don't know, add one, add two, add three. Whatever different types of state changes you need to make, you can write your reducer to handle those. So there's no limit here. As long as you can differentiate between the different types of state changes you need to make, you can write your reducer to handle those. I mean, I could have a switch statement that's like, and like, yeah, as DP says, you can define your own types, whatever you need to do. You know, maybe it's add, change, delete. Maybe it's add one, add two, add 100. Maybe it's, update user, log out user. I don't know, show error, change error text. You know, whatever you can think of. You write. You are in control here. That's the cool part, right? You define the different types of actions that you're passing in the message. You're the boss. You can do that. So once we've done that, we've made our change or returning that updated information. Now that's the new state that gets set as the new state. We trigger a re-render of the entire list, and now my new text is displayed in the list. Okay? Hopefully that helps a little bit. Seeing how we walk through. Really, all we're doing is it's just the user is the boss in this case. They're performing an action. As soon as they do that, they click a button. Then we write a message. Our event handler says, oh, they clicked me. I need to write a message real quick. That message contains instructions on exactly what the subordinate, the reducer, needs to do. And what we pass into that reducer is the raw materials, which is the current state, and then the instructions, which is the message we just wrote. And then the reducer finds the appropriate actions to perform based on that message, and then updates the state and delivers the finished product, which is then shown in the UI. Okay, good deal, Tenor. I'm glad that helped. Yeah, Tenor, it's conditional to match which task it is going to change. Yep, and then it sets the state based on that. Exactly right. You got it. Okay. And as I think Zena mentioned earlier, so you can even isolate your reducer functions to a different file and then import the use reducer to the file you need to call it. Yeah, and so you can, as they say down here, you can move the reducer to a different file if you want. Like we talked about earlier, you can import just about anything. And we've seen before how you can have different components in different files if they're doing different things, and then just combine them together inside of your app.js, right? You can import a bunch of different components from different files, and you'll see that. Oh, good, Champo, I'm glad. And you'll see that a lot in React apps. You'll see different components stored in different files because it can get real complicated real fast if you have all your components in the same location. You have to scroll up and down and ugh. Oh, good, Drunken Roma. I'm glad. Good. And see, that's the thing, right? Like if, one person asked the question, but it helped, well, actually two people asked the question, but it helped more than just them. And so that's why I always like to stop and explain. It's never a hardship for me to go back and explain again. You're not going to inconvenience me. You're not going to make me, annoyed at you or anything like that. Feel free to ask. Because it's always going to help someone who's, not able to. Oh, you're good, Drunk Uncle Grandma. Don't worry. I was making waffles and lost track of time. Hey, if you're going to be distracted by anything, waffles are a pretty good thing to be distracted by, I got to say. And so here they're just showing an example of how they move the reducer. It's the same thing. They just move the reducer to a different file, and then all they had to do was import it. So very easy. And that's the magic of React, right? Is we can just import, we can store stuff elsewhere and we can import it. And really it's the magic of, you know, JavaScript in general, right? We do this in our MVC apps. We store our MongoDB uh, schemas, right? We store our Mongoose schemas in separate files so they don't clutter things up, and then we just import them wherever we need them, right? And that's what we're doing here. We're just saying, all right, I don't want this gigantic, you know, ugly reducer cluttering up my main code. I'm just gonna chuck it in a separate file and then import it, and then React will still know where to find it. So no biggie at all. And now, once we've done that, that makes our, you know, app.js much simpler and cleaner. Much, in my opinion, much easier to read. We're hiding all that nastiness out of the way. So component logic can be easier to read when we separate concerns like this. I agree. Now the event handlers only specify what happened by dispatching actions, and the reducer function determines how the state updates in response to them. Yeah. So we're separating concerns. That is a true separation of concerns, right? Where this whole part in the app.js just defines what's supposed to happen, and then behind the scenes, our reducer is actually making it happen, right? We're hiding the logic behind sort of the facade here. So it's separation of concerns, just maybe a slightly different way of looking at it than we're used to. However, if you want to just put everything in the same file, you can do that too. It's JavaScript, right? It doesn't matter. Everything is made up and the points don't matter. That's the magic of JavaScript. Okay, so this is a good point to pause. We're going to take a 5-minute break. When we come back, there will be a kitten, maybe more than one, because I think I see both Drunk Uncle Grandma and Madeline here. So they have both claimed naming a kitten rewards. So pause, pun intended. Yeah. So I think we're gonna have double kitten, and yes, and by kittens I mean real actual kittens, like meow meow kittens. Yeah. Um, so I foster kittens for the Humane Society, and so one of my channel rewards is to see and or name a kitten. So if you're interested in that, rack up the channel points, and you too can name a kitten. Hmm. Grandma says, "Is there a mustache kitten for Mavi?" No, no mustache kitten. Um, you'll see what they look like. They are beautiful kittens though. They're very cute. So you'll see them when we get back from break. I'm gonna bring two kittens in, and well, maybe three. I don't know if I can like wrangle three kittens at once, but we'll see. We'll see how it goes. Yeah, and then Madeline and Drunk Uncle Grandma can pick the two that they would like to name, since they already redeemed their channel points to do so. So 5 minutes. Oop, what's going on there? Google, stop it. Google's hidden the timer again. There we go. Okay. See you back here in 5 with kittens. Don't go away. It's going to be cute. But do get up and stretch. Don't just sit there the whole time. You're not going to miss anything as long as you get back in 4 or 5 minutes. Go hydrate, do whatever you got to do. All right, see you back in 5. Okay, folks, we got about a minute left in the break, so come on back when you're ready. And yes, I do have kittens. Um, you will see them in just a minute. Got them here with me. I brought all three in their little carrier, so you'll get the chance to see all three. Godzilla says we never left. Yes, we'll look at that after kitten time, Depetka. Okay, remind me if I forget. All right, we'll look at on change task together. Don't let me forget. But kitten time first, and then we'll look at that. All right, it's time indeed. We are stopping the timer. I am going to go to my different screen here. Let's see. Oh, camera. Why camera not working? All right, hang on. Oh, wait, no, I didn't turn it on. Okay, that's why. Come on, camera. There we go. Okay. Got a little bit of a bigger screen for you here, so all the better to see the kittens with. So they none of them have names yet, as I mentioned before. So Madeline and Drunk Uncle Grandma, you can feel free to claim them as we go. They are all the same color. They're all beautiful, sort of a buff sandy color. Two of them are larger, one of them is smaller. And so let's take a look. All right. Yeah, so this is kitten number one. Yeah. They're about 4 weeks old ish. It's a little hard to know. With uh, when kittens come into the animal shelter, they often don't have their mom, and so you just don't know how old they are. Um, so yeah, this kiddo is very cute. Obviously, there we go. Say hi to the camera, baby. I know it's bright lights. I know it's okay. It's okay, sweets. She's a little concerned. Oh. Zena says, "Oh, this one looks so different from past kittens." Yeah, yeah. I don't know that I've ever had like sandy colored kittens like this before. I'm trying to. A lot of my kittens have been, gray, black and white, tabbies. But yeah, very beautiful sandy color, very squirmy. Oh, kiddo, it's all right. It's okay. Where are you going? Oh, I know. It's okay. It's a little concerned. Yes, baby. It's all right. Yeah, there you go. Yeah. Okay, so let's look at another one. All right. This little baby is the smallest one. Yep. She's very cute, though. Another little sandy baby. Yeah. I don't know if you can hear her, but she's got this adorable little squeaky that she does. Yeah, there we go. Squeaky baby. Yeah, little baby lion. Yeah, I know. It's a baby. I know. Yeah, you're okay. And they've got these lovely little stripes on their legs. You can see there. Yep. Yeah. So she's the smallest. She's the runt. There's usually a runt in every litter. Um, she's the small one. Okay. Yep, always a runt. And then here's kitten number three. Um, Looks basically identical to kitten number one, but I hope I picked up the actual third one. I'm not entirely sure. I still have a hard time telling them apart. They're little twins, um, basically. Here, let's just get both of them. See, I don't want you to miss out. They all look the same. There we go. So these are the two big ones. They're twins. Oh, it's okay. Yeah. So, Drunk Uncle Grandma, I think actually, so Drunk Uncle Grandma claimed one to name Rick James, and I believe actually the first one to hit they wanted the first one to hit another kitten. I believe was actually our little friend there, a little runt. So the little runt can be named Rick James. And Madeline, did you have a preference on which one of these two kiddos you wanted to name? Unless, whoop, sorry if I missed it. There's chat's been going by and I haven't been able to scroll back up. I'm also getting covered in tiny little sandy colored hairs right now. Matrix, was it the same cat twice or two different cats? Yeah, that's why I brought them both on screen so you could see I wasn't lying to you. Oh, she's in my hair. Okay, all right. They're feisty. They are. That means they're healthy, though. For kittens, that's good. Yeah, that one of them is sneezing in my hair right now. Yeah, they're very feisty. Kozulu says Swahili name for cat is Paka. Oh, that's good to know. Okay, I'm gonna put them down so I can scroll through chat and make sure I didn't miss anything. Okay. Oh goodness. Whew. Okay. Happy Kitten Mother's Day. Yeah, absolutely. So yeah, I hope you enjoyed that. I don't see Madeline on here, but bring them back, please. I wish they could hang around for the entire stream, but being kittens, they're very, like you said, they're very feisty. So they like to be rambunctious and wild, and so they would not be good stream companions for if I actually want to be able to interact. But you'll see them more. I'm sure as time goes on, as they get bigger, I will be bringing them back. But Drunk Uncle Grandma, I'm happy to name the little one Rick James if you're good with that, or if you prefer one of the other ones, that's fine too. Whichever one you like to name, and then Madeline is also needs to claim one as well. I will get with Madeline. I think they had to leave, um, but I will get with them later to claim whichever one they would like. Okay, all right. No worries, Drunk Uncle Grandma. I will decide. Thank you for the hydrate, Tenor. Chris says you should have a kitten cam similar to how Time Enjoyed has a bird cam. I've thought about that. Yeah, I need to buy another webcam though in order to do that. I only have one webcam. But if I buy another webcam, we could have a little live kitten cam situation going on in the corner. Yeah. All right. Well, I hope you enjoyed that. Feel free to ask questions, about the kittens or fostering if you have questions. I do hope to do a stream just on general, like how to be a kitten foster at some point. That's still on my radar to do. Um, good. I'm glad you liked it. But yeah, give me just a minute. I'm going to put these guys back in their little enclosure in the other room, which, maybe I'll set up a camera in there someday. And then we'll get back to talking about we're going to finish up talking about reducers, and then we'll move on to context. All right, one sec, I'll be right back. All right, I'm back. The kittens are settled back in to their little play space, and let's get back to the content. As much as we would all like to play with kittens for the entire stream, we are actually here to learn something, maybe occasionally. Back to reality. Whoop! There goes gravity. Nice one, Jinketta. Good to see you, Code Zulu. Thanks for stopping in. Drunk Uncle Grandma says, by the way, any good SQL review sites for foreign keys and normalization? Mm, I think SQL Bolt is generally a pretty good SQL review site. I don't know how much it has about, specifically foreign keys and normalization. Those might be a little bit more advanced for that type of site. I'm not really sure. Mm. Yep. Okay. And the pet cat had a question earlier about our let's see. Let me remind myself which one it was. Depetka says, can you show where on change task gets defined? I missed that. Is it a custom event? Yeah. So what's happening there is they're asking about this. Yeah. And so what we're doing here is we're essentially just using this to pass through our event handler. Okay. So, and we're passing that into our task list. Unfortunately, they don't have the task list code here for us to look at it, but I think we'll see a better example when we get down to the challenges at the bottom of the screen. And so what we're doing here is we're just saying, hey, on when a task is changed, call this event handler. So if we were able to see the task list code for this component, we would see where this gets defined. I think we'll see another example of that when we get down to the challenges. So just bear with me for another minute, and when we get to the challenges, let's look at an example of an event handler and how that gets incorporated into a component. Yeah, it's a custom on change essentially. Yep. But let's look at an example when we get down to the challenges, because they don't have, like, I can't they don't have the actual code for the task list component here. Did that? I mean, I know I'm kind of like postponing your question a little bit, Depetka, but is that still what you wanted to look at? I just want to make sure I'm got the right thing in my head. I'll assume it is, but correct me if I'm wrong. All right, well, we're going to get to the challenges here very shortly, and we can look at that together. So we talked about, let's see, basically, so we've talked about use reducer this entire time, but okay, no worries, that's great. But let's just do a quick comparison of use state and use reducer. So what are the differences? And somebody asked about this earlier. They were like, hey, so what's the point, right? Like they understood the, like, conceptually what use reducer is for, but why do I want to even use it? Like, what's the point? Why? And so this is kind of trying to answer that question a little bit. Why would we use one versus the other? First example here is code size. So with use state, generally we have to write less code up front, right? With use state, we don't have to set up our dispatchers. We don't have to like offshore our reducer into another component in a different file. It's going to be less lines of code probably because you can just incorporate use state directly into your event handlers. With use reducer, you have to write both a reducer function and your dispatch actions, right? You have to write your messengers and then the reducer function to handle those messages. But use reducer can help cut down on the code if many event handlers modify state in a similar way, right? So if you have a lot of actions, if you have a lot of actions that are updating the same state just in different ways, right? Update, add, delete, all those different types of things that you could do to that particular state, then that might be a time when you would want to switch to a reducer because it's going to reduce the complexity of what you're trying to do. Yeah, and Dev says, yes, I was thinking reducer would inherently reduce the amount of code and was confused when it didn't seem to. Yes, exactly. You are correct. It's not necessarily that we are reducing the amount of code, but it's more of like, the name reducer doesn't seem generally intuitive. I'd like to think of it more as like a collector or like a consolidator, right? It's taking all these, separated, disparate pieces of state updates, and it's just consolidating them into one place. Yeah, and as your app gets larger and you're having a lot of different interactions with the same piece of state, that's when the reducer is going to come in handy. Yeah, because you at some point things are going to get too scattered, and you're not going to know you're not going to be able to remember or find all the different ways that your state is being updated because they're all going to be in different places, right? If you're just using use state everywhere, you're not going to know where all that stuff is happening, and you're going to try to change something or fix something, and you're not going to know all the places you're going to have to touch. If you have a reducer, you can just lump those all into a single reducer, a single switch statement, and just go through the different possibilities. Okay, so readability. Use state is very easy to read when state updates are simple. When they get more complex, they can bloat your component's code and make it difficult to scan, just like we talked about. In this case, reducer lets us cleanly separate the how of our update logic, so our messages that we're sending, from the what happened of event handlers. Sorry, so the how of the update logic from the what happened of the event handlers, which is the messages that we're sending. And then debugging, like we talked about, right? If we're just doing everything with use state, it can be difficult to tell where the state was set incorrectly and why. With use reducer, you can add a console log into your reducer. So just put a console log right in the reducer function to see every state update and why it happened, right? You could just do a single console log statement and, have that trigger at whatever point you need it to, right? And you could just write the action that triggered it. So you could have a console log at the end of your reducer, and just pass in the action into that console log and the message that you sent, and you would know exactly what type of state update was called with a single console log. If each action is correct, you'll know that the mistake is in the reducer logic itself. If you wanted to do that same thing with use state, you would have to put a console log in each event handler, right? And then also it can help with testing. A reducer is a pure function that doesn't depend on your component. This means that you can export and test it separately in isolation. Because, we can even have it in a separate file, right? You can, force it to assert that your reducer returns a particular state for a particular initial state and action, because all you would need to do is pass in your test values into the reducer, right? Pass in the action, pass in the message, and then see what comes out. And that can confirm that your state update is working correctly. So you could pass in some hard-coded values if you wanted, whatever you want to do. And then personal preference. Just like with anything in JavaScript, it's all made up and the points don't matter. So if you like a particular way to do it, then do it that way. Whatever you want to do. It's all good, man. Maybe you never use it. Maybe you'll never use reducer again in your life. And that is okay. That is allowed. Whatever you want to do. Whose code is it anyways? Exactly. It's all made up. You can always convert between use state and use reducer. They are equivalent. They recommend using reverser if you often encounter bugs due to incorrect state updates in some component and want to introduce more structure to the code. You don't have to use reducers for everything. That's the important part. If you're building a small app, then you don't need it, probably. I mean, you can just use, especially if you have like a few pieces of state and you're only updating like each one individually, like you don't need a reducer for that. Or you can use state and reducer in the same component. There you go. They have a couple of small tips for writing good reducers. Reducers should be pure. Uh, Similar to state updater functions, reducers run during rendering. This means that reducers must be pure, and the same inputs must always result in the same outputs. They should not send requests, schedule timeouts, or perform any side effects, such as operations that impact things outside the component. They should update objects and arrays without mutations. And this is the same thing that we talked about when just talking about regular state update functions, right? They need to be pure, they need to be self contained within themselves. And they need to take in what is given to them and not modify what has been given to them, right? They can perform actions inside of the component, they can do logic, but they can't mutate what they've been given as, gospel, right, from the parent. And each action should describe a single user interaction, even if that leads to multiple changes in the data. If a user presses reset on a form with 5 fields managed by a single reducer, it makes more sense to dispatch one reset form action rather than 5 separate set field actions. So if you log every action in a reducer, that log should be clear enough for you to reconstruct what interactions or responses happened in what order. Yeah, so essentially all they're saying here is that if we are taking a form with 5 fields and we want to reset all of those fields at once, we should send a single reset message saying reset all the fields rather than 5 separate individual messages for each field in the form. By convention, one user interaction equals one message to the reducer. That's just what they're saying there, is that if we want to do a single user action, we should send a single message. We're going to skip this section on Immer. If you want to read that, you can. Immer is just a separate library that you can use to do stuff like this, but we're not going to muddy the waters here. We're going to skip that part. All right, so going to recap what we talked about here. To convert from use state to use reducer, we dispatch our actions from event handlers. So our event handlers become messengers, right? To send messages to our reducer. From the boss, we want to send a message from the boss to the subordinate. And so we use a messenger to send a memo from the boss to the subordinate. And then we write our reducer function that returns the next state for a given state and action. So into our reducer, we pass 2 things: the current state and then the instructions for what we want to do to that state, right? And then the reducer reads the message that we've sent, reads the instructions, and then performs certain actions based on those instructions, and then returns the updated state. And then we replace use state with use reducer as our keyword, as our hook, hook. Reducers do require a bit more code. They help with debugging and testing. Reducers must be pure, just like state updaters. Each action describes a single user interaction. So a single button press should send a single message, no matter how many form fields it updates, right? You should send a single message. And then you can use Immer if you want, which we didn't talk about. All right, so let's do a couple challenges. So we've looked at this sort of example before. This is a chat app. Very simple chat app, but I think a fairly applicable piece of code, right? Chat apps are fairly common. You may want to write your own. Office Space memo for TPS reports. Exactly, that's what it is, right? What's the boss's name on Office Space? What is it? Lippert? No, Lemming? Something? I don't know. The quickest way to get the right answer on the internet is to be wrong. So I'm sure now that I've been wrong, someone will have the right answer in chat. That's how it works. Sending a memo to update your TPS reports is just like that. Dispatcher, user triggers the event handler, sends the memo, and then the reducer updates, adds or deletes TPS reports based on the memo. Lumberg. I knew it started with an L. Thank you for that. That was like a watching that movie was no, it's yeah, hey. I would have believed you if you said you just knew it. Lumberg, yeah. I watched that movie uh when I got my first internship. We watched it, with my fellow interns. We watched that in our little company provided apartment when I had a summer internship at an insurance company, and it was surprisingly accurate, even in the mid 2010s. Great movie, fantastic movie. All right, so what do we want to do here? Currently, our event handlers in contactlist.js and chat.js have a couple of to dos. Okay, we want to replace the to dos with the code to dispatch the corresponding actions. So they want us to write the dispatchers. They want us to build the messages that our reducer is going to use to update the state. So in order to figure out how our messages need to look, we need to check the reducer in this file right here. The reducer is already written, thank goodness. You only need to dispatch the actions in contact list and chat. So let's look at the reducer. What is the reducer doing? And I'm actually going to fork this to a new window so you can see it better. And also too, you should do this, right? If you have a smaller screen, if at any point you can't see the code, just fork it to a new window, and that'll open it in a much larger screen, and you can adjust that. You can adjust the window size. Okay, so how does our reducer look? We're taking in the state, we're taking in the message, and we have a switch statement here. It takes in two cases, right? One of them is that we have a change. So I'm assuming that corresponds to changing between the message recipients. And then the other one is that we've actually edited the message in the box. So, excuse me, I need to scratch my nose. Okay, there we go. Juketta says, can I spoon it instead? Hey, whatever you want to do, right? It's JavaScript. You can do whatever the hell you want. All right, so this is what our reducer is expecting to take in, right? Dr. Moda says, you were picking it, don't lie. No, I was scratching it, but I want to, I don't want to show that on stream. Come on. Thank you for the follow, Sky Zismo. I hope it wasn't because of the nose scratch. All right. Drunk says, I'm so used to if else instead of switch case. I need to practice some katas with that. Yeah. A lot of folks don't like switch statements, but I find them really useful, especially when you get into larger numbers of possibilities, right? When you get into multiple conditions, if else can get a little bit cumbersome. But like I said, there's nothing wrong with either one. Use whichever one you like, but you should be able to use both. So these are our two options. And this is what the reducer is expecting to get from the message that we're sending it. And we're being asked to build the message. So for a change selection, that's the switching the recipient, it's taking in the state, right? And we're already passing that in. So that doesn't need to be a part of the message. We're already passing in the state. However, it's expecting an ID. And I think that's it, right? In this case, for changing our selection, it's really just expecting a contact ID to know who to change it to. And then for our second one here, for our second message, our second dispatch, it's taking in the state, which we're already giving it. And then it is expecting a message from that object. So inside of our message, it's expecting the chat message that we're trying to send. So I'm seeing a couple slightly different structures here, but that's okay. We can set up two separate dispatches with different message types. All right, I'm going to go back to the actual code here and going to take out this to do. I wish it would. There we go. All right. I'm going to take out the to do, and then we're going to set up our message. All right. So inside of contact list, we have our on click. So that's our event handler. And on click is going to send. So if I want to set up, if I want to tell React that I'm going to be sending a message, how do I tell React where the message starts? What keyword do I need to use? What's my keyword to say, hey, React, I'm sending a message? Yeah, dispatch. Okay, perfect. And then inside of dispatch, what am I building? What are these messages? What JavaScript thing is it in general? What do I? It's just okay. Well, it contains strings, sure, but I want. What if I want to contain? I want to contain multiple strings in the same thing. So what is that? If I want to contain multiple separate strings in the same bundle, what is that? What do we call that in JavaScript? We might have multiple key value pairs inside of this thing. Arrays can do that. Object. Yes, it's an object. Exactly. And it's an object because we need those key value pairs. We can't just do an array. We need that we need to name the things that we're including inside of this object. They need to have specific names. And so in order to do that, we need to use objects. So I'm going to do that. I'm going to fix my parentheses. Yeah, so inside of our dispatch, inside of our message, we have an object. And then by convention, what should every single dispatch message have in order to tell our reducer what action we're trying to perform? What do we call that? How do we name that action inside of our object? Yeah, exactly. Tenor said it, and Yarmo said it as well. It's a type, right? So by default, anytime you send a dispatch, it's going to have a type. Okay. And then the type that we want to match up with this is, I need to remember what it's called. I believe that would be, let's see, the contact list is change selection. So we need to match this type so that when it goes into the switch statement, it's going to see case change selection, and it's going to know that we want to change our contact person. All right, so our type is going to be this, change selection. All right, and then the other thing that I need to include in my message is, we already have state, but I need contact ID, right? That needs to be the other thing. That's what our reducer is expecting. It's expecting to look inside of the message and find something called contact ID. Okay, and again, that's why we're using an object here, because we're looking for a named item which could contain a string with whatever we want, or a number with whatever we want. But it's always going to be named contact ID. Contact ID, I think that's right. Contact ID then is going to be essentially just our key here. We already have the key, so contact ID is going to be that. Now, there we go. Now, look at that. If I switch between my recipients, I hope you can see that. Now, if I switch between my recipients, I can see that it is successfully switching between the various chat windows. So my message is being dispatched read by the reducer, and the state is being updated. Each time I'm clicking a new button, state is being updated and the correct chat window is being displayed. We can tell it's working because the UI is updating correctly. All right, so that's one message. Now we also need to, and I can see that's, yeah, it's not even letting me type in the box because that's the second message that we need to send. We need to tell it to update the message when the user interacts with the chat box. Okay, so and that is going to be in our chat.js. And it's telling us we need to send our message here and we need to read the input value from, what does it say? e.target.what? Get this. e.target.value is what we want to read the message from. All right. All right, so once again, I'm going to set up a dispatch. And inside of that dispatch, I'm going to build an object. And that object is going to have a type, right? What is my type going to be for this one? Somebody look at the reducer and tell me what the type is for this one. I can pull it up here on screen too if we need to. So we've already done change selection. So what's my type going to be this time? Edited message, correct. So I'm going to literally copy and paste because I don't trust myself to spell correctly. Oops, sorry, wrong file. There we go. Type is going to be edited message. And then looking at the reducer, what's the other thing? Yes, Yarm is right. That's correct. What is the other thing that I need to pass in my dispatch? So if we look at our edited message case here, it's returning, we got the state that's already being passed. What's the other thing that I need to send in my message that the reducer is expecting? Message. Yeah, exactly. Chaotic Rage and Yarmo, you're correct. Yep. It's expecting something called message, which is literally just the contents of whatever the user has typed in the box. Okay, so I'm going to go back and say, all right, it's looking for something called message. I'm going to give it something called message. And then it told us in the to-do, I shouldn't have deleted the to-do, but it told us what we were supposed to take in as the message. And it was just e.target.value. They told us that explicitly in the instructions. They said, this is what you need to read as your message. So we're passing that to our reducer. And now if I type in this box, you can see that it's actually updating. And now, once I switch away from that, it re-renders, and so the message gets deleted. But now the message is being passed to the chat box and displayed back to the user. All right, go us. Good job, us. So that is how you can construct a message and then dispatch that message to a reducer. And so let's go ahead, and while we're here, I'm going to go back to my larger screen here. I want to look at make sure I get the right name here. Sorry. The question about the Depetka, yeah. So Depetka, if you're still here, I wanted to look at the event handlers a little bit. There was a question about how do the event handlers work? Like what are these things that are happening here? So we have the full set of code here, so we can look at each component and how these things are used. So all we're doing here is we're passing these are when we reference a component such as chat or contact list, right? These are actual components that we're referencing. What we can do is we can pass in certain values as props, right? And those values can be a variety of things. And we can see that we're doing that here. And actually, we're not, let's see. Well, that's all right. We're passing in a few different things, right? We're passing in a key value as a prop, contact ID. We're passing in message. We're passing in contact. We're passing in dispatch information. We're passing in the selected ID. And those are all being passed into this component as props. And so if we go into the component itself, let's look at chat. If we go into the component itself, we can see that those props are being read. Our component is expecting those props and it reads them in, right? And so we can do that same thing. We can do that same thing with event handlers. Sometimes we may want to pass event handlers from a parent to a child as props so that the child can call the event handler, which is defined in the parent. The child can call the event handler, which is defined in the parent, and then trigger that event handler to run and update state in the parent. That's one reason we might want to pass an event handler as a prop. And so when you see something like what's happening here, this is really us just passing things from the parent to the child. So we can see, like, for example, message. We defined message as state.message up here in the parent, and then we're passing it down to this child component as a prop called message. Okay? Does that help, DepTech, if you're still here? So I think in the earlier example, what we were seeing was the same thing. And I unfortunately not passing any event handlers down here, but in the earlier example, it was just a prop where they were passing an event handler down from the parent to the child as a prop. And you can call that prop whatever you want, as long as you make sure that the child component is expecting it. If the child component is also expecting a prop called message, then, I could call this, I don't know, walrus. And then if I go into chat and say walrus, and then, just do a replace anywhere, walrus. There we go. It works. It's expecting walrus. I give it walrus. It works. There you go. You can call it, Dr. Moto says it breaks if you call it Spanish Inquisition. Because nobody expects the Spanish Inquisition. That's correct. As long as you don't call it that, then whatever you want is fine. Hope that makes sense. I think there was a question earlier too from QuasiDev. Hello, this VOD will be on your YouTube channel. Yes, it will. I'm going to be I've actually done another set of exports to YouTube. I haven't made them public yet. I need to go through and, tweak the descriptions and things like that. Pick a thumbnail and all that sort of thing. But yeah, I have like another 3 parts of this series that are ready to be posted publicly on YouTube. I just haven't done it yet. But yeah, they have been transferred. But all my streams are also available on Twitch for 60 days until they expire too. So whatever your watching preference, although I will say that my YouTube channel is nice because it doesn't have ads. And so if Twitch ads drive you up the wall, then you can watch them on YouTube instead. Exclamation point YouTube if you need a link to my channel. All right, so hopefully that makes sense. Let's see, I'm thinking about how many examples we want to do here. What's the next one? I need to remember. Thinking about this? I think this one is, I think this one is pretty simple. We can do this one. All right, what do they want us to do? Currently pressing send doesn't do anything on this particular example. And they're correct. Add an event handler to the send button, so to this button right here, that will show an alert with the recipient's email and the message, and then also clear the input. Okay. So two things: it needs to throw an alert and it needs to clear the input. All right. Oh, thanks, Mr. Carson. All right. So yeah, if you subscribe, you should get, hopefully, I don't know how YouTube is weird, but hopefully you'll get notified when my next chunk of videos go live. So I think what we're going to need to do is edit this button right here. So this is our send button right here. They want us to add an event handler to it. So, okay, we're talking event handlers here. I want to, actually, I don't want to delete the text that was in there necessarily. All right, we'll just do this. If I want to capture an interaction with this button, what event handler should I use? There's a lot of them out there, but there's only a few that get used pretty often. So what event handler should I use if I want to register the standard interaction with this button? I'm trying not to say it out loud. What's the best handler for that? Yeah, on click, right? Exactly. Now, one thing that's important to remember when you're well, I'll do it wrong first so you can see. When you're adding event handlers to buttons and to other elements, let's see what happens. I'm going to go ahead and I'm going to add my event handler, okay? See if you can figure out what I did wrong. Let's see, on click, and then I'm going to like do a bunch of stuff, and it's going to need to be an arrow function. Oh no, it doesn't like it. What did I do? What's wrong with this picture? Unexpected token? Why doesn't it like my event handler? What did I do wrong? Ah, yeah. Yarm is quick on the draw. That's correct. My event handler is outside of the element, right? Because it's basically what it's trying to do. And you might catch it. Let me go back a little bit here. If I just do this part, you can see it's trying to include it as text within the button. And so it's trying to handle it like, you know, just displayable text. And that's not what we want. And so in order for it to treat it like a proper event handler, it needs to be inside of our button tag. So I'm going to change my formatting here a little bit. I'm going to move the closer there down just a tad. And then how do I want to do this? Probably like something like that. There we go. So it's still erroring out because we haven't put anything inside of our handler yet. But now we should be able. There we go. That looks better. So now we should be able to properly declare our event handler. All right, so on click, what do I want to do? Well, first thing I want to do is show an alert. That's pretty easy. How do I do that? An alert is just that little box that appears at the top of your screen when you do something that doesn't let you continue until you acknowledge it, right? It's just, it appears at the top of your Chrome window or Edge or whatever. Yeah, it's very simple. We just say alert. That's built in. That's something we can just reference, and it has certain properties. So, and they just want to say, show an alert with the recipient's email and the message. Okay. So we can just say sending. I'm going to use template literals here, but you can do it however you want. Sending should have the message information. We have the message value, right? That's the message value itself is already being passed in as a prop to our component. So we have that information. So I can just say sending message, and then I can say to, and then whatever their email is, which I think we should also already have. I think that's in the contact object, theoretically. Let's try it. Contact.email. Contact.email. Got close parenthesis there. Okay. Let's try it. Yay, it works. Sending hello to taylor@mail.com. You probably can't read that. It's probably too small. But so the alert is working correctly. So that was the first thing they wanted us to do. And then the second thing they wanted us to do was clear the message input. So how can we do that? Well, one way we could do it is just tell the reducer to display an empty input box, right? Just tell the reducer, clear me. I want to be an empty input box, clear me. So let's look at our reducer here and see what options we have. So just like we looked at before, we have either when we flip between different contexts, we can do that. But that's not what we want to do. I think our other option here is we can use edited message and just send it a blank, right? You can just say, all right, message has been edited. They clicked send. We're going to edit the message and make it blank. So all we need to do is just pass it a dispatch with an empty message, right? I think so. I lost my place. Where's my button? Oh, it was in chat. Yeah, sorry. There we go. Okay. So second thing we're going to do is build our dispatch. With an object, the type is going to be edited message. And then the message itself, message itself can just be blank, I think. Ta-da! Let's see if it works. I'm going to do a test there, send to Taylor. Okay, sent and cleared. Do the same for Alice. Hello, Alice. Sent. Sending hello, Alice to alice@mail.com. Click OK and cleared. Yay! I think that did it. Okay. Now, I do believe in the solutions, another way you could do it is by building another case into the reducer to, essentially say like sent message or clear message or something like that. If you want to consider it as a separate case, I mean, then you would set up a separate dispatch for that. And I don't think it's entirely necessary in this particular example. I think sending the message and then clearing it still kind of counts as an edit, but that's, semantics. If you feel like it makes more sense to add a separate case for sending the message itself and then clearing the board, that's up to you. You can absolutely do that. Let's see. I think it's time for a break. Third Decade suggested a poll. How well do you know use state versus use reducer? Use docs for help. So Third Decade, what's the question? I guess what feedback do you want from the poll? Like, what should the options be for people to choose? And Drunk Uncle Grandma says, at that point, it seems redundant, like creating another use state for default null. Yeah, I kind of agree. I don't think it just for that specific action, I don't think it needs a separate case. But again, it's all made up and the points don't matter. So you can add a separate case if that's something that you feel strongly about. Okay. Third decade says maybe 0 to 5. How comfortable with comparing the two between use state and use reducer? I get the feeling I already know the results, but I'm happy to set up the poll for you. Referring to the docs section that we covered. Okay. Yeah, I can do that. Yeah, I can set up the poll during the break. Um, I think we're going to go ahead and go on to the next section, passing data deeply with context. This one's pretty important. And again, I do want to get through these last two if we can before we wrap up for the day. But I would highly suggest doing example 3 because I feel like example 3, like do that one on your own, and because I feel like it's useful in the context of a chat app. It basically it's figuring out how to set up storing like draft values of a message. So if I type hello into this box, and then I switch over to Alice, and then I switch back to Taylor, I would want that hello message to stay in place, right? I wouldn't want that state to get reset. I would want to preserve that and store it. And then reset that message, when I'm switching between the various recipients. I want to be able to save drafts essentially. And so I think this is a great example for that. Although I do want to go on to the next section. I think this is a good one to do on your own. And remember, don't feel bad if you need to look at the hints. This one actually has a hint, which is good. Telling you how to restructure your state and telling you what types of things to use. But don't feel bad if you got to look at the solution either. That's okay. Once you look at the solution, go back and do the problem yourself without looking at the solution if you can, and then just keep iterating until you can confidently get the solution without looking at it first or looking at the hint. So definitely do example 3 yourself. Example 4, do it if you want. I don't think it's that valuable. It's just basically writing the reducer, like the use reducer ability that's built into React, like writing that from scratch. Which, okay, sure, if you really want to understand what's under the hood, you can. I didn't do it. But if that's something you're keen on, if you want to know why it works, how it works, this is something you can do. But again, I would highly recommend example 3. Depetka says, from my point of view, it seems to be useful. Reducer, it seems to be useful mostly when you have to deal with multiple event handlers and you want to group similar behaviors together. Exactly right. That is correct. If you're dealing with a bunch of different interactions against the same piece of state, right? If you have multiple different ways that you can interact with a single piece of state, for example, maybe selecting something from a drop-down menu and then clicking an edit button, clicking a save button, clicking an update button, clicking a delete button, all the different CRUD type of actions that you could perform against a single piece of state, then reducers are great for consolidating all of those different actions into a single place so that it doesn't become confusing. So also think about it in the wider context too. In most cases, when you're dealing with an actual UI, like a full featured UI, a React UI, you're going to have multiple pieces of state going on simultaneously, right? Multiple pieces of state for multiple components getting moved around, getting passed around. And in that context, consolidating all of the actions for one of those pieces of state into a reducer and using multiple reducers to kind of bundle things together for a single piece of state might be useful when you're dealing with multiple states at once, like multiple state variables at once. So thinking about larger picture, that may be where you find this useful. Yeah, yeah, that's great. Yeah, Depetka really phrased it like you would a Banky question. Absolutely. Yeah, I like that. Okay, but your homework is to do example 3 in this section right here. So do it or don't, I don't care, but that's your homework. See if you can do that one. And then, you can build your own chat app. After that, you should be able to build your own chat app if you want. All right, we're going to take a break. It is break time. And then we're going to talk about this is actually the topic I am more excited about today. Reducers are great and all, but we already know how to use state, right? So whatever. This is what actually this is the topic I'm more interested in today. So I'm looking forward to talking about it after we get back from break, passing data deeply with context, and learning about prop drilling and what happens when our UI gets too deep for its own good and we have to pass a prop all the way down through it. How can we handle that in a smarter way and apply a single prop to multiple tags at once? How can we not have to apply the same prop multiple times and instead apply it once to a bunch of different elements all at once? That's context. Yeah, and Depetka, I think we talked about you may have been gone. We talked about the event handlers, and so we were looking at the forked code and going through the event handlers. And yes, it's always good to remind folks that you can see the full code by forking it, um, and you can click through the various files and see how they all link together. If you need a more full screen view, I think that's very helpful. Yeah, we what we did earlier was we talked about props, and how we can rename props any way that we want. We named this one Walrus, and we saw how it flowed from the parent to the child. It doesn't matter what you call it, as long as the child is ready to receive it, right? Oh no, it's okay, Depetka. Don't worry about it. All we said was that you had a question before about how where did there was like an on something, right? And it was taking an event handler that we had built. It was taking an event handler and it was passing it into something. It was said like on change or something. And you're like, where did on change come from? What the heck is that? Well, it's essentially just whatever we call this prop. So we built a prop called on change. We pass in the on change event handler as this particular prop, and then we set up the child component to listen for that prop and be ready to use it, to pull it down and use it. Okay, so you can name that whatever you want, but generally, if we're passing an event handler as a prop, it starts with on whatever, on change, on click, on whatever you want. It starts with on and then what's happening. And that's how you name that prop. Yeah, so I think in the example we were looking at before, the thing that you were asking about, it's a custom name prop containing an event handler that's getting passed from a parent to a child. Okay, good deal, Depetka. Awesome. All right, break time. I'm going to set up a timer, and then we're going to talk about context. Okay, 5 minutes. Please do get up, get a drink of water. We've been sitting for a while. Well, you've been sitting. I've been standing for a while. You've been sitting. Get up, do the opposite of whatever it was you're doing. Uh, get a drink of water, whatever you need, and then come on back and we can talk about context, which I think is very important and very interesting. All right, see you back in 5. Okay, folks, we got about a minute left in the break, so come on back whenever you're ready. If you sat through the whole break, even though I told you not to, uh, please do get up and stretch. If you're able to do so, move your arms, move your neck, move your wrists. Nobody wants carpal tunnel. It ain't fun. Stretch your body. I gotta go retrieve my water from the table. 1 second. Okie doke. I'm gonna stop the timer and turn on the camera. And we're back. Hello, hello. All right, let's talk about context. As with most things in life, context is very important to consider, right? Um, just in general, context, the word context refers to sort of taking in information surrounding so if you're looking at a topic, right? Um, the lens through which you view that topic needs to be considered with the surrounding information. So the things that are adjacent to that topic also need to be considered. That's context. Um, so if somebody is maybe getting annoyed with you and you get angry with them, you need to think, wait, maybe why are they annoyed with me? Maybe they had a bad day. Maybe they, you know, have been on the line with customer support for 2 hours, right? That's additional context that can help you understand the reason for the why they're feeling that way. Nothing exists in a vacuum. Everything has context. Everything has related information that feeds into and out of it. And so that's what context means in general, but in the context of React, the word context has a specific meaning that we're going to explore today. All right. So usually we'll pass information from a parent to a child component via props. We're very familiar with that at this point. We take props, we bundle them up, and we pass them from parent to child. The child is set up to receive those props. Drunk Uncle Grandma says, by the way, Mindwolf, I've been using your examples to explain React at meetups and referencing your Twitch streams. You're starting to get known in Tennessee meetups. Oh, thank you. Thank you. Thank you. Yeah, I saw your message on LinkedIn. Thank you for that. I'm glad my examples resonate. Sometimes they make sense to me, but I don't know, if they make sense to anyone else. And so I'm glad that they do, at least to you and to maybe other folks at your meetup. So thank you for that. I appreciate it. All right. So passing props go from, parent to child, right? We bundle information up into an object called props and we pass it from the parent to the child. Easy peasy, right? But what if we have a parent and that parent contains a child and that child contains another child and that child contains another child and we have a prop, for example, maybe something that's style related, right? That we're setting let's say we're setting like light mode or dark mode for a component, right? And all the children inside of that component should also be dark mode. So thinking about this window right here, right? I'm sure that we've got multiple nested components on this page that we're looking at right now. We have a parent wrapper, we have a sidebar, we have this sidebar over here, we have the article content, we've got this header stuff, and we can switch between light mode, sorry, burn your eyes, light mode and dark mode, right? And every child, as soon as I click that button, every child under the parent component of the page also has to switch from dark mode to light mode. And so somewhere there is a dark mode prop that's being passed down from a parent to every single child on this page. And sometimes that can be pretty deeply nested. So how do we do that, right? Light mode. Yeah, sorry. So how do we do that? Passing props can become verbose and inconvenient. Verbose just means wordy, like too many words. verbose and inconvenient if you have to pass them through many components in the middle, or if many components in your app need the same information, such as dark mode. Every component on this page needs to know whether it's supposed to be in light mode or dark mode. And so if we have to pass it every single time, multiple times, that's, I don't know, doesn't make sense. It's not dry. So context lets the parent component make some information available to any component in the tree below it, no matter how deep. So any component can reach up all the way to its top parent and get the information it needs. We can bypass those middlemen, all those middle components. We can bypass them, and the child can just go and grab exactly what it needs. We don't have to pass it explicitly through props. Inheritance grandma's car. Yeah, yeah, exactly. Reminds me vaguely of prototypal inheritance. Yeah, sounds kind of familiar, don't it? Yep. Okay, so let's learn about prop drilling, how to replace it with context, common use cases for context, and alternatives. So passing props is a great way to explicitly pipe data through your UI to the components that use it. But passing props can become verbose, or if many components need the same prop. The nearest common ancestor could be far removed from the components that need data, and lifting state up that high can lead to a situation called prop drilling. So here's an example, right? So in a case such as this, passing props normally is no big deal, right? We have one parent with two components, and it's trivial to just pass the prop to each of them. It's done one time, it takes no extra effort, and it's explicit that we are sending the prop from the parent to the child. No problem. However, red leather, yellow, yeah, these React docs contain tongue twisters, the magnitudes of tongue twisters, absolutely. Here is an example of prop drilling. So the source for the prop is here in the parent because it needs to be, right? Each of these components need that prop. And so their nearest common ancestor is up here. However, in order to get a prop from here all the way down to here, we need to pass it 1, 2, 3, 4 times, which is a little excessive, right? We don't want to do that. That becomes confusing. It becomes easy to forget, one of the times you're supposed to do it. It's going to get muddied up with, if you're not using the prop and you're just passing it through, it can be confusing when you see it in this component. You'd be like, why is this prop here? Why do I need it? You might not realize that the child is the one that actually needs it. So wouldn't it be better if we could just teleport data to only the components in the tree that need it without passing props? For that, we use context. So here's an example of why we might want to use that. This is a style. It's a styling example. So this heading component accepts a level for its size. So the level value determines the size of the heading. Dr. Moda says, this scares me because it reminds me of global variables, which they taught us were the devil. I think it's more controlled than global variables. And once we see more about how to apply it, I hope that becomes apparent. But I would say it is not, I would say it's not equivalent to global variables. M's and rems for font style. Yeah. Depends on how you're doing your styling, I guess. So let's say that you want multiple headings within the same section. So remember, section here, section, this section has multiple headings. In this example, they're all different. But what if you wanted some of them to be the same? So in this example, we have a title, and then we have some headings. They're the same size. We have some subheadings that are the same size, and then some subheadings that are the same size. I swear the tongue twisters in this are, they're nuts. So how can we do that? Here we're, explicitly declaring the levels, right? We're hard coding them in, which, it works, but it's not necessarily the best way to do it, right? If only there was a way that we could pass in that value and have it be dynamic, right? Just pass it in as a prop and then have it show up automatically without us having to do any hard coding. It would be nice if you could pass the level prop to the section component instead and remove it from the heading. Yeah, and even simplifying it further, right? What if we didn't even have to repeatedly declare the level value, right? This is repetitive. Why do we have to do this? Why couldn't we just say, hey, everything in this section right here should be level 3? All the headings underneath should read as level 3. We don't have to repeat ourselves. Don't repeat yourself, right? Dry. Let's just set it at the section level. Hey, little robot. Good to see you. Oh, thank you, little robot. All right, so what if we could pass it to the section component and remove it from the heading? This way you could enforce that all headings in the same section always have the same size. You're never going to make a mistake. But how can the heading component know the level of its closest section? That would require some way for the child, the heading, to ask for data somewhere above in the tree, to look upward and say, hey, what's going on up there? We can't do that with props alone. This is where context comes into play. Remember, talking about the word context, it's the additional related information that feeds into whatever we're looking at. In this case, it's the section wrapper around those headings. So the first thing we'll do is create a context. We'll call it level context. We'll use that context from the component that needs the data. Heading will use it. And then we provide that context from the component that specifies the data. Section will provide the context. So that's confusing, but we're gonna look more at it. Context lets a parent, even a distant one, provide some data to the entire tree inside of it. So very powerful. And I think you'll see context be used quite a bit in styling and like repetitive actions like this. Especially thinking about like, variable list items and things that have variable amounts of contents, right? You would just want them to automatically read the same information from their parent without having to explicitly pass it. All right, step 1, create the context. So the first thing we need to do, again, we're bringing in a new element, we're bringing in something new. And so just like with anything else, we need to import it. So we're going to import create context from React into a new file called level context. And then we're immediately going to export. We're going to create the initial context and we're going to export it so we can use it elsewhere. So here we're just saying, all right, I'm going to be using context for something, right? We import the concept of context from React itself, just like we do with use state, use reducer, all those things we already talked about. We import the concept and then we create our specific implementation of that concept. And we're going to export it. So we're going to have our level context and we call create context and give it a value of 1. So what does that mean? Well, the only argument to create context is the default value. Here, 1 refers to the largest heading level, but you could pass any kind of value, even an object. So it's basically just like when we set up state, right? We set up state and we give our state an initial value. We're doing the same thing here. We need to give our context a default value to start with, which we're probably, immediately going to modify in most cases, right? I'm gonna set my heading size based on what location I'm at. However, we initialize it with a default value and then modify it later. All right, step 2, we actually use the context that we've exported. So we import the use context hook, and then we import our context. So two imports here. One is the context we just created. Two is the ability to use it. Okay. So next thing we're going to do is modify our heading component to use context instead. Now we'll see how this looks in full a little bit later. It's a little confusing in this, condensed form, but we're going to remove the prop that we were passing previously. We don't need that prop anymore because we're using context now. Instead of explicitly passing a prop, we're using context. We remove the level prop and we read the value from the context we just imported. So use context is a hook, just like use state and use reducer. You can only call a hook immediately inside a React component. Use context tells React that the heading component wants to read the context. Makes sense. Okay, so now our section doesn't have to look like this anymore with us explicitly passing a level each time, right? We don't have to repeat ourselves anymore. Instead, we can set the level at the section. We can set the level at the section, and our heading will be configured to read it. Okay? Now that might be confusing just looking at it in a vacuum like this. So let's look at it as a whole, as a unit. So this is how it looks as a unit. We can see at each section, we're setting a level, and the headings underneath it are able to read that level from their parent and display accordingly. Okay? Now, it doesn't quite work yet. It's reading it, and that's fine. It's, functionally it works. But all the headings still have the same size because we're using the context, but we haven't provided it yet. React doesn't know where to get it. So it's reading the default value that we created when we built the context. So the last thing we need to do is step 3, which is providing context. The section component currently renders its children. You can see that there. It uses it takes in the children prop and it renders a section with child content inside of it. The last thing we need to do is wrap the children in what we call a level context provider or a context provider. Okay? And that is how we say, hey, section, give the context to your children. You can see it's almost like a little intermediate prop value, right? So parent, level context, and then what are we passing down? We're passing down the numeric value of the level to all the children inside of it. This tells React if any component inside this section asks for context, give them the value. The component will use the value of the nearest context provider in the UI tree above it. Clear as mud, right? Still makes 0 sense. That's okay. Let's look at it again. Let's look at it again. So now we can see that things are working, right? We have our title, and each of our headings is reading the context and determining the correct size. The level is being declared at the section and then being passed down to each heading beneath. Okay, so let's look inside of the heading component real quick and see, because there's nothing here indicating, oh, hey, it's asking for a level, right? We're used to seeing props being passed down to sort of give us a visual indicator that something is being read in. But in this case, we don't have that. So let's look here. Okay, let's look inside of the heading component itself. So heading is grabbing use context, right? It's going to be reading something in, and the context itself, which is stored here. So each heading is going to grab the context from the parent. It's going to grab the context from the parent, enter a switch case, and determine how big the header should be based on that context from the section. So that's how the magic is happening, right? We're doing a few things here at once. We're teaching our heading how to use context, how to read it. We're getting the context itself, which is set to 1 by default, just like we do state. And then we're calling use context. We're calling use context, which is going to see if it can read the nearest context from its parent. Then when it grabs it, it enters the switch case. But how do we make that context available to read? Let's look at the section. The section is where we want our headers to read the context from. So in order to do it, we need to provide the context to the child. To do that, we set up a level context provider. Okay? So we make that context available. It's now available for its children, which is all the headings. The headings is able to read it and use it, and then deliver the appropriate size. Whew, that's a lot, right? But let's look at it step by step again. So what did it do? Now our headings figure out the proper level by asking the closest section above them in the UI tree. You pass a level prop to the section, right? We pass that to the section. Section wraps its children, the headings, inside of a provider with whatever value we gave it. Each heading asks the closest value of level context above by calling use context. Okay, so there's a couple steps there, right? We need to create the context itself. We need to use the context, so the child needs to be set up to be looking for context from its parent. And then the parent needs to be set up to provide that context to the child using a provider. Okay? Anything starting? I hope it's starting to glimmer a little bit with what we need to do. If we just think about it in terms of 3 steps, right? We build the context first. We set up the child to use it. And then we set up the parent to provide it by wrapping a provider around the children. We're going to see more examples of this. Okay. So what we're doing currently is still specifying each section's level manually, right? Inside of our section, we're passing in a prop, and that prop explicitly declares the level. These are all we're doing here is we're just saying, all right, section component, pass in a level prop explicitly. Since context lets you read information from a component above, each section could read the level from the section above and pass level +1 down automatically. So we can make this fully automatic. We don't have to pass props into each section even. We can do it once, and then we know that this is going to go in sequence. Each nested section is going to be level +1, right? And so in order to do that, once again, we follow the steps. We set up our context inside of our section. We set up our provider. But instead of passing in the level itself, we just say level plus one. And that way, for each nested component, it's going to add one to the section and then pass it down to the children. So with the change, we don't need to pass the level prop either to the section or to the heading. So let's see how that looks now. Yeah. There's zero props being passed here at all. No props at all, right? Nothing. Nothing at all. Nothing at all. Nothing at all. Deep cut Simpsons reference. So without looking or with looking, I mean, I'm not going to stop you. How do we know where to start, right? How does our context know that this is supposed to be level one, this is supposed to be level two, level three, level four? How does it know that? Right? We know that, yeah, okay, it's going to, for each nested section, it's going to add one to the level. Okay, fine. But this is an H1 right here. So how does this section, the top one, how does this first section, the top one, know that it's supposed to start at level one? You can look, I won't know. They give you the answer down below. You can tell me that you got it of your own volition, even if you didn't, or if you did, hey, that's great. I'm going to believe you either way. What do you think? How does this section know that our context starts at one? Think about when we set state. When a page it loads initially, we want to have a default layout. How do we do that? It's the same principle as when we set state. I'm going to hydrate. Anybody know that underground show, The Simpsons? Hey, Georgie. Hello to you too. Ah, yeah. Nerf Baller, got it. Great name, by the way. I love it. Their decade says default function. Yeah, absolutely. You're both right. You're both right. So, if you recall, when we set up our context, right? When we set up our context, we give it an initial value. And so, in this case, we set the initial value as 0. And so, the first time that context is provided from that section to its children, it says, all right, initial value plus 1 is 1. There's your H1, and then it all cascades from there, right? It works because whenever we create context for the first time, we give it an initial value. And so you can do whatever mathematical operation or whatever logic you want on that initial value within your context provider to make it cascade down through each child. Exactly. Dipetka is right as well. Exactly. Yep. So both heading and section read the level context to figure out how deep they are. And the section wraps its children in level context to specify anything inside of it is at a deeper level. Yeah, so it's just iterating upon itself. Each time we go deeper by one level, it adds 1 to the context. This example uses heading levels because they show visually how nested components can override context. But context is useful for many other use cases too. You can pass down any information needed by the entire subtree. The current color theme, like for example on this page that we're looking at right now, light mode versus dark mode, that seems like something that's needed by the entire page, right? The currently logged in user, also extremely useful. When you have a user that's logged in, you want to display certain information and hide other information, right? You would want to hide a login box. You would want to show specific information related to their account. And all of that depends on probably a binary, like a, a Boolean of whether or not that user is logged in. That's something that every component is probably going to need to know, or most components. No matter how deep they are in the UI tree, they need to know whether that user is logged in. And so you can pass anything down via context that you want: numeric, strings, objects, Booleans, whatever. All right, so let's see, with that in mind, let's see how we can pass context through intermediate components. So things in the middle that may not need it. You can insert as many components as you like between the component that provides the context and the one that uses it. This includes both built-in components like divs and components you might build yourself. So Depetka, in this case, Depetka is asking, in the previous example, where we defined the level for each section, we could have avoided declaring the first section since it would get the default value 1, right? In this case, the way they built the logic was that they changed the default to 0. It's probably kind of hard to see, but they changed the default value to 0, that a little bigger, instead. And that's because the context provider is just doing a level plus 1 each time. So each time it provides information down to the children, it's adding 1 to it. So let's think about it this way. The first section, the top one in my app.js, this one right here, okay? This one right here. Let's follow through what it's doing. It's taking in the level context from levelcontext.js with an initial value of 0. It's assigning that to a variable called level. It's grabbing it and saying, all right, I'm going to use context. Level at this point is equal to 0. That top section is taking in the context, setting the value as level plus 1. So the first time it gets assigned, it's 1. Okay? Exactly, Nerfballer. It's iterating itself. And so we need to think about the behavior on the first iteration. And so on the first iteration, it's still going to add 1 because that's what we've told it to do. So we need to start with 0 instead. Yeah. And as far as like avoiding declaring the first section, the way this is built, we really can't do that. We're assigning this behavior to all sections. We're inside of our section component and we're saying for every single section, do this. Now, I suppose you could set up a separate component and call it separately for the first section, but why do that, right? When you have a workaround, you can just start at 0 instead and it'll iterate correctly. Does that make sense, Depetka? Well, let's see what happens if we set it to 1, right? We can do that. Yeah, no reason to do that. Absolutely. We don't need to declare that first section separately because we can just change the initial value to be whatever we need it to be. So if I set the initial value to 1, now everything goes one size smaller, right? Because we're iterating from the first round. Now, if I set it, let's do this. I'll set it to -1. Whoa. And the reason it did that was because we just tried to pass 0. We tried to pass 0 into our section. Oh, did you mean this example up here? This one here where context was set to 1? Section. Okay, let me read through that. All right. Oh, you were asking, could we just do this? That still won't work. Now that's what I love about these docs, because you can literally, try it. Just remove chunks out of it and see what happens. No, it's still expecting a prop. Every section, that's the thing about React. is that if you set a component up to receive a particular prop, whether you need the prop or not for that particular iteration of the component, you still have to pass it in, right? Our section, this section right here, is expecting two things: a level prop, which is explicitly passed in, and children, which are being passed in within the tag itself. Yeah, it still needs it, even though the value is technically already one in our declaration. Exactly, you're exactly right, Depetka. In our declaration of the component, we said you will always receive a level value. So we still have to provide it. But if you ever wonder about these sorts of things, yeah, just give it a try, right? Just go into the example here and nuke the code. Do whatever, yeah, break it. That's what it's here for. So that's what I love about these docs, is because all these examples, you can edit them. And then once you break it thoroughly, then just click the reset button up here in the top right. Just click that and reset the whole thing. V. Dillinger, thank you for the follow. So the reset button is your friend. Also, the fork button is your friend. All of these examples are infinitely customizable. Yeah. All right, let's see. Where were we at? We were at intermediate components. So we just talked about how, we saw how things can get passed down. Dillinger, hey, hello from Italy. Hi. Hello from the US. Good to see you. Hope you're having a good day. We're talking about React. Nerfballer says this is a great feature, exudes React energy that will help JS devs how to think in React. Yeah, these new docs are great because it allows you to just go in there and smash stuff, right? Break it, reset it, break it again, whatever you want to do. Okay. In this example, the post component, which has this dashed border here, I'll zoom out again. This post component with the dashed border is rendered at two different levels. So we can see it's rendered here. And then there's a couple of non-dashed things. And then it's rendered a couple levels down again with the dashed border. So the heading inside of it gets the level automatically from the closest section. All right, so let's see how that works. So our post is, okay, so this is recent posts. It's getting a title and a body right here. And then if we look inside the post component, I bet what we will see, oh, they don't have the code for the post. Oh, wait, no, it's down here. Never mind. I bet what we will see is some styling. So if I look at heading, yeah, so heading is expecting a level, right? And it's expecting it from, I suppose, probably the closest section, because I think section is going to be, again, providing, yep, section is going to be providing a level to its closest child. So no matter where that heading is, it's going to look up to its closest section and get the level information that it needs. So if we look again, we can see that this section has a heading inside of it. And this section down here also has a heading inside of it. And so no matter where that heading is, as long as it can locate a section above it, it's going to be able to grab the information it needs. Doesn't matter where it is. So we didn't do anything special for this, right? We didn't structure the code differently in any way. It was able to, the section was providing the context. The heading was looking for context. It was set up to use context. And so wherever that heading is located, as long as it can find a section above it, it's going to grab that context. Dr. Moto says, I only smash things outside. Well, now you can do it in this sandbox right here in the React docs. So we didn't do anything special for this, right? A section specifies the context for the tree inside of it. The tree here meaning any of its children, like headers or whatever. So you can insert a heading anywhere and it will have the correct size. Yeah, so let's do that. I'm going to put another heading down here. So I'm just going to do that. Heading. I'm just going to call it test. Yeah, so we can see that this heading has the same size as the one above it. It's reading its level from the parent section, right? It's reading the level from the parent section. It's kind of hard to see probably, on this screen, but there's a clear size difference as we go down the tree. And we can see how the headings are reading from the parent above it. You can experiment with that yourself. Try putting headings in various places and watching them change size based on where you insert them. Actually, let's move this one. Let's take it, move it up a level. I'm going to put it, let's see, I'm going to put it all the way up here. So this should be pretty big. I'm going to put it just below, right here. There we go. So now if I put it at the top level, at the same level as profile, it's much larger because it's reading the level from its parent section. Okay. So context. Context lets you write components that adapt to their surroundings and display themselves differently depending on where they are being rendered or in what context they're being rendered. And this might remind you, we talked about prototypal inheritance a little bit before, but it might also remind you of CSS inheritance. So we can specify like color blue for a div, right? And any DOM node inside of it, no matter how deep, will inherit that color, right? If I specify color blue for a div, I expect that color to bleed through to all of its children. Thank you for the follow, Juniju. And then we can override it in the middle, but by default, if I color a div blue, I expect that div to be blue unless one of its children is explicitly colored something else. That's just something we kind of take for granted, right? If I fill that div with blue, the whole thing should be blue. And that's what we're doing here. That's what context is doing here. In React, the only way to override some context coming from above is to wrap children in a provider with a different value, just like we would if we explicitly declared a child element to be a different color than its parent. In CSS, different properties like color and background color don't override each other. You can set all divs color to red without impacting background color. I wish they would have said affecting there, but whatever. Similarly, different React contexts don't override each other. Each context that you make with create context is completely separate from all the other ones, and it ties together components using and providing that particular context. So it's just like state, right? Individual states can be declared separately and used separately and don't have to affect each other. One component may use or provide many different contexts without a problem, like state. Now, somebody asked before, why don't we just use context for everything, right? It sounds great. Why don't we just use it all the time? Here's some things to think about. Context is very tempting because it sounds like magic. We can just teleport information, from the mothership to any of the ground forces, no matter where they're at, right? They could be, buried 20 units deep, and we can just pass context right to them. That makes it easy to overuse. Just because you need to pass props several levels deep doesn't mean you should put that information into context. I love it. They basically just said it politely, Just because you can doesn't mean you should, right? You should always start by passing props. If your components are not trivial, it's not unusual to pass a dozen props down through a dozen components. It may feel like a slog, but the advantage is that it makes it very clear which components use which data. The person maintaining your code will be glad you've made the data flow explicit with props. I would say that's the main advantage, is that the flow, where the data is going and where it comes from, is explicit with props. We saw a little bit earlier in some of those examples how if I was just looking at app.js, I had no way to tell what information was being passed from parent to child, right? If we're in context, all of that is hidden. It's disguised. It's hidden within the components themselves. And we can't see in the bigger picture in our app.js. That's all, it's not visible. We can't tell where is that coming from, what it is. Um, you know, there's no way to see it. And so if I was, Joe Schmo coming in to look at Larry's code and I just had no previous introduction to it, I'd be like, oh crap, like how is this even being styled? Like where is this coming from? I got to look inside each component to find to find how these context is being calculated. Now, hey, if it's your own code, again, do whatever you want, right? But you might think about when explicitly spelling things out could be to your advantage. Another thing you can do is extract components and pass JSX as children to them. If you pass some data through many layers of intermediate components that don't use that data and only pass it further down, this often means that you forgot to extract some components along the way, right? If you're bypassing intermediate components, it could be that you forgot to extract some components along the way. For example, maybe you pass data props like posts to visual components that don't need them, such as layout. Instead, make layout take children as a prop and render layout as a wrapper with posts inside of it. So if you're trying to differentiate between content and styling, you might think about taking layout, making it into more of like a styling tag, a wrapper, and putting posts inside of it. This reduces the number of layers between the component specifying the data and the one that needs it. Again, it's up to you. If neither of these approaches works, then consider context. So now, on the flip side, why do we want to use it? Why is it a good idea? For theming, just like I talked about, right? Dark mode. That's actually, I didn't realize this, but they actually give that explicit example. You can put a context provider at the top of your app and beam it down to every single child component to update their visual appearance all at the same time. And then current account, we talked about that already. You need to know who's logged in. You might want to wrap part of the UI in a nested provider with a different account value from another. Mr. Carson says, sorry to interrupt. Don't know if you said this already, but will you be putting all modern React VODs on YouTube? Yes. I have another batch that are not currently visible to you at the moment. They're already in YouTube. I just need to update the descriptions and the thumbnails and all that annoying administrative stuff before I publish them. But yeah, I have another batch ready to go. I think the first 4 parts maybe are on YouTube already. And the next batch of 3 or so videos is ready to go. I just need to finish with those little admin tasks before I publish them. But if you're subscribed to me on YouTube, you should hopefully get a notification when those videos go up. Exclamation point YouTube in chat if you need a link to my YouTube channel. It's also ad-free. YouTube is ad-free. I don't monetize my YouTube channel so that you don't have to deal with ads. So hopefully that is helpful. All right, another reason you might want to use context is routing. Most routing solutions use context internally to hold on to the current route, right? Because you need to pass that route from item to item as you go, and they need to hold on to it. This is how every link knows whether or not it's active. If you build your own router, you might want to do this too. And then, managing state, right? We looked at that. We talked about that a little bit earlier. You might have one component all the way over here in the tree that needs it, and then another three components in a different branch of the tree that also need it. And their earliest common parent is way up at the top of your app. So as things get more complex, you might end up with more state closer to the top because it's needed by multiple children at various branches in the tree. It is common to use a reducer together with context. We just talked about reducers earlier in the stream, right? To manage complex state and then pass it down to distant components without too much hassle. That's what we're going to look at next. To put a bow on this entire section of the React docs, we're going to look at a short section at the very end, how to use reducers and context together in order to build larger, better organized apps. So context is not limited to static values. If you pass a different value on the next render, React will update everything reading it below. Makes sense. And we often use context in combination with state. In general, if some information is needed by distant components, it's a good indication that context will help you. All right, so once again, 3 steps to creating context. First, we initialize the context. We give it a default value to start with the intention that we will be updating that value as needed as we pass it down through the various components that it's going to. Next thing is we pass it to the use context hook to read it in any child component. So any child component that needs it, all we need to do is call use context. All we need to do is call use context in order to read it. And then we set up the parent to provide that context to its child so the child can read it. So those are the 3 steps, and we'll get to practice that. There's one challenge question, and we'll practice that in our challenge question. So context can pass through, can teleport through any components in the middle. It lets us write components that adapt to their surroundings. We can also, if you can, try passing props the traditional way or use children, but that's not to say that context is something bad or something you shouldn't use. You just need to know the limitations. I think my main consideration with context is that, once again, it's not visible. It operates behind the scenes a little bit in the components themselves, and so it might not be immediately obvious where that context is coming from. All right, we'll do a challenge. We'll take a break, and then we'll power through this last section. This last section, I promise, it's very short. It just kind of ties things together. It's the rug. The rug really ties the room together, and then we'll be done with this entire section of the docs themselves. All right, so let's do the challenge. So what do we need to do here? Replace prop drilling with context. In this example, toggling the checkbox changes the image size. We can see that. Passed to each image. The checkbox state is held at the top level app component, but each place image needs to be aware of it. Okay. Currently, app, so the top level component, passes image size to list, which passes it to each place, which passes it to the place image. So we've got 2 middlemen there that don't need to know image size, right? They don't care. They're just passing it through. So we're prop drilling. So we don't necessarily want to do that. Instead, we're going to remove the image size prop and instead pass it from the app directly to the image itself. Part of the doc we just scrolled over that said day off in Kyoto. Oh, I missed that. Yeah, there's a lot of little subtle references in the docs to various things. I dig it. It's fun. Okay, so let's look at this. So we're in app.js. I might need to actually, I'm going to fork this. It'll be easier to read. Okay. Yeah. So we can kind of see what's going on here. So app is calling list, right? And it's passing image size. However, list is not using image size at all. It's just sending it straight through down to place. And again, place doesn't care either. Place itself doesn't care. It's passing it just straight through down to place image. Okay. So let's look back at the steps here about I know we want to use context. Like that's explicitly what we want to do. So let's follow the steps and use context. Hey, intelligence, long time no see. How you doing? So the first thing we need to do is create the context, right? So I can tell that they've given us a file to do that. It's empty. So what do I need to put in this file? If I want to follow the steps, step one is create the context. What do I do? Just in a general, you don't have to tell me specifically, but in a general sense, what do I need to do? There's two things I need to do in this file in order to initialize the context. How do I create my context or initialize my context? I'm gonna hydrate. I'm getting a little scratchy. Anybody know? We can break it down a little bit more if we need to. So I'm starting from scratch here in this file, right? I'm starting from nothing. However, I already know I'm doing something with context in here. Ah, code for dopamine. That's a great place to start. Yeah. All right, we're going to import. First, we need to import the concept of context, right? So in order to create context, I need to create the context for creating context. Well, I need to import it. That's all we need to do. As a general sense, just remember that whenever you're dealing with something new or different in React, a new type of hook or anything like that, the first thing you should always do is import it. Okay? So that's the first thing I need to do. Now I can create context. So in a general sense, how do I do that? You can think about it similar to the way that we're creating state. You don't need to give me the exact statement, you can give me a general sense of what is something I need to do now to initialize my context. It's very similar to creating state when we initialize state. Yeah, exactly. Two things. We export and we set the default value, right? Export. And we can, let's see, did they give us a name for this? We can just call it, so image size is the prop. So I'm going to call it image size context. Don't need to get fancy with it. And then we've imported create context, right? So we can call it and we just set a default value. That default value, let's see. Ooh, Girl with Box. Thank you for the raid. Hello. How you doing, Girl with Box? Oh, Faffin, good to see you. Hey, Owen. So we are talking about React and we're talking about using context. So I need to set an initial value for this. We're just doing a quick challenge here to teach us how to use context. Girl with box, hey, good to see you. Thank you so much for the raid. What were y'all working on today? I think I'm going to set my, just for starters, I'm just going to set my initial value to 100. That's just 100 pixels. And Girl with Box says they changed React. I heard they did. Yeah, the documentation is now it's now function based rather than class based. So we're learning function based React with hooks. Yeah. Oh yeah, good call. I forgot my const. Good catch. I forgot to say const image size content. Yep, because we're setting a variable there. So that's correct. All right, that's all we need to do inside of here. We've set up our context now. We can import it elsewhere. We've exported it, so now we're able to import it. And we set our initial value. So that was step one, right? We've created our context. And next we can use the context. And then number three, we can provide the context. But good catch, Code with Dopamine. You get a cookie. All right. So inside of app.js, the very first thing I need to do is I'm bringing in new information that I didn't already have, right? So I need to import it, not impost, import. I can just do that and I can say, what did I call it? I've already forgotten, image size context. And I'm just going to grab it from context.js. Let's see. Oop. Oh, capital C. Sorry. There we go. Hey, enjoy your dinner, Girl with Box. Baffin says, "Good thing I didn't know anything about React. I have to unlearn." Hey, sometimes that's an advantage. Aquafunkalistic Booty Whap. Wow, that's a great name. I know React exists. Hey, that's a good start. I actually have a whole. This is part 8 of a series that I'm doing on React, and so you can always start with part 1 and pick up React from the very beginning if you want to. It's on my YouTube channel, ad free. So exclamation point YouTube if you want to see that. If React is something you want to learn, start with part 1, ad free on my YouTube channel, and catch up. Not knowing things wins again. Dr. Moto says it's kind of hard for React because the old docs don't use hooks. So if I Google a problem, I see things I don't understand. Yeah, I find that ChatGPT is helpful in that case. So you can ask ChatGPT and you can specifically say, use hooks or don't use hooks in the answer, and it will attempt to create the answer based on that information. So just FYI, ChatGPT could help you there, narrow it down. Okay. I should figure out that chat. It's easy. It's free. Yeah, you can play around with it for free, and I think you'll find it very useful. I've done a couple streams on it. If you want to look at those, we built an entire full stack app using ChatGPT. Nothing but English language GPT prompts, and it was the free version too. Not even the paid version. We built the front end, we built the server, we built the database, schema stuff, all that using nothing but English language prompts in Chat GPT. It was really fun. We also did a React app in GPT with nothing but English language prompts. Dr. Moto says, is it for 3.0? It's 3.5 is free. Yeah. Okay. Code for Dopamine. Oh, you're catching up on the section of the doc still. Okay. All right, so what did we just do? We imported our context, so now we can use it wherever we want to. So inside of app, let's see, I don't think we need to change anything there. However, let's see, where do we want to? We're going to need to make our context available for our list items to read. Well, let's do it in order. So let's say, all right, use the context. So I need to go into my place image, right? This is the thing that actually cares about image size. So this is where I want to set up my use information. So outside of my return statement, I'm going to prepare my place image component to read the context from the top level. So const image size, oh, sorry, lowercase I, image size. What function do I need to call in order to make my component able to read context that's provided by its parent? What do I need to call? Makes you give your phone number. That's why I haven't done it. Yeah, it does. They don't want bots. I'm sure they get them anyway, but they're trying to limit bots. So what do I need to call if I want my component to be able to read context? Not provide it, but read it. What function do I need to call? Use context. That's correct. Yeah. So, and that's a good point too. We did because I forgot to import it as well. So good catch once again. So I'm going to go ahead and declare it here. Context. Oops. Call it here. I mean, use context, and I can say, all right, you're going to read image size context, just like that. And then I'm also, we can see it's erroring out because it doesn't like that. So I'm going to also import it up here. Use context. All right, perfect. Now the other thing I need to do is get rid of my image size prop. I no longer need that. I am teleporting image size, right? I'm beaming it down straight from the top level into my image component. So I can also get rid of it here. And all those middlemen, I can get rid of image size. We don't need it anymore. And I think I can get rid of it here too. Yeah. Clearing it out, clearing house. Cool. Okay. I think we already, we did, oh, Code for Dopamine says, not sure what this does. Import level so level context was just the specific name of that context from that example. So context is itself a thing, and then you can give it a custom name. Okay. So inside of our context.js, we called ours image size context because that's what we need for this example. That other example called their context level context. So that's why that is the way that is Code for Dopamine. Yeah. And so we are importing image size context because that's what we named ours. Okay. Yeah. Antonio, friend needs help with SQL. I would ask ChatGPT, honestly. If they need a certain syntax, I actually use that for work. I will ask it questions on how to correct my syntax or find errors in my SQL statements. GPT is great for that. It's very good at SQL. As Dr. Moto just said. Okay, so we've got it reading the context, but now it's only reading the default value. It's only reading the default value because we've only done the first two steps. We've created it and we're using it, but it's only reading the default value. And I can prove that by changing the default value from 100 to 200. See? Everything got bigger. It's all reading the defaults because we haven't done step 3. Okay? So let's do step 3. We need to make sure that we are providing the context to be read. So it's always going to be appropriate. So when we provide context to be read by the children, we need to make sure that our context provider, that tag that we saw before, right? Context provider tag is wrapping all of the children that we need to contain. So we just need to locate them, all the things that we want to wrap. Yeah, Antonio, I'll answer your question in just a second. I just want to finish this example, then we can talk about that. All right. So let's see. I think I'm going to need to put this wrapper. So our list contains all the children that we need to talk to. So I'm going to need to put the wrapper. Actually, yeah. So okay. Let's think about this. So I'm setting image size here is large. I'm going to need to put it. I think I'm going to need to put it here. I think I can replace this empty tag here, which is with I'm just gonna replace this empty tag that's not doing anything anyway. I'm just gonna replace it with my context provider. So I can say image size context dot provider, and the value that I'm providing is image size. And I need to wrap that in brackets. Okay, and now I need to put the proper closing tag on there. So that'll just be image size context dot provider. Theoretical. Oh, wait, here. There we go. Okay. Let's see if it works. Hey, it works. Boop, beep, boop, beep, boop, beep. Cool. Because now any child inside of this whole section, no matter how deep, no matter how many nested components we have, this is our image component is like 3 levels deep, right? Doesn't matter. Now that I've wrapped everything in this provider, it's like radio waves, right? You can think about it like a radio tower or a cell phone tower. I've built my cell phone tower to cover a wide range of the landscape, right? I'm gonna sneeze, hang on. All right. My cell phone tower or radio tower is broadcasting all over a whole city. Now, is my radio always going to be tuned to the channel that's broadcasting from that tower, right? To that radio station? My radio is not always going to be tuned to that radio station. However, if I were to tune my radio to that station, I could pick it up anywhere in the city, doesn't matter where. And then as soon as I turn my radio away, that's fine. It doesn't matter. It's still broadcasting no matter what. And so that's what this context provider is doing. It's just blasting this context over everything beneath it, over the whole city. And then as soon as one of the people down there in the city, no matter where they're at in the city, as soon as one of those people tunes their radio to that channel, they can pick up that station. So as soon as one of these components down here, no matter which one of these components that's in range of that context provider says, hey, I would like to use context, please. They have tuned in to that radio station and they can pick up the context, no problem at all. Okay. And any one of these components could use it without an issue. Dr. Moto says, are there performance issues with using context versus passing state? Slightly different things. So I think you mean passing props, right? Versus passing props explicitly down. My answer is I don't know. I mean, maybe once you get really big, I really don't know. We'd have to look that up and see if there's any performance issues at scale. Like if you were, I think maybe if you weren't smart about like where you put your context provider, right? But I guess no, in some of the examples that they specified, essentially you would be wrapping your entire like your top level component in that context provider. So you're providing context for the entire app. And that's one of the use cases that they specified, is that, hey, maybe you want to do this for your entire app and wrap the whole thing in a context provider. And they suggested that, right? For dark mode versus light mode. That may be something you want to do. So it seems like it doesn't make a difference if they're recommending that there may be times you do it for the entire app and to reach every single component. So there you go. It seems, again, it seems to me that the main disadvantage of context is that you lose that explicit path of where the props are coming from and where they're going. But the thing is, so Dr. Moto, it's important to think that the thing is you're not really blasting it across the entire app. You're making it available, but it's only being picked up if use context is called. So it's really only moving if use context is called. Yeah. But that's an interesting question. I don't know the answer. Um, yeah, it might be worth a look. Um, so here's my question to you all. I really want to get through this last short section here where we talk about um, combining reducers and context. Do you all want a break? Do you want a 5-minute break and then we go back to this, or do we want to just finish up? It's up to the group. I want to be respectful of, people's needs and health. Um, so either way is fine with me. Let me know. And Antonio, while y'all are thinking about that, Antonio says, do you know what is going on with 100 devs and when is the next cohort? I do not. Unfortunately, I don't have access to that insider information. You need a break, okay. Leon is holding things pretty close to the chest when it comes to the next cohort. He's certainly, he's taking his time with it, right? Because there's been such seismic changes in the landscape of development at the junior level, right? Since the last cohort, with the rise of ChatGPT, changes in libraries, changes in tools, a lot can change in a year and a half, right? So much can change, and so I know he's working on really revitalizing the cohort, making it different, making it sure it stays in step with what junior developers will need to know. And so I don't know the timeline. I apologize. One thing I am working on, maybe potentially doing, don't hold me to this, but is doing kind of like an office hours thing once a week on Twitch for beginners who are starting out, to kind of do office hours with them, for folks who are pursuing it on their own, and just to give them a little helping hand as they pursue the cohort on their own, and so they don't have to wait for the next cohort to start. But I haven't fleshed that out fully yet, so still rattling around in my brain. I'll let you all know if and when it does happen. But that's not in collaboration with Leon in any way. That's a personal, personal endeavor. Yeah, Antonio, I don't know. I don't have any inside baseball there. Okay, we need a break. All right, 5 minutes. And then when we come back, we're gonna blow through this last section, and then we'll be done. All right, resetting the timer. See you all back here in 5. Get a drink, go stretch, do what you got to do. I'm gonna go take care of the kittens, and then I will see you back here. Okay, folks, we got about a minute left in the break, so come on back, come on back. The kittens are doing good. Just checked on them. So that means we've got time to finish up this entire section of the docs with a very short little recap of reducer in context. I hope you got yourself a drink of water, whatever else you needed to do, and you're feeling ready for the home stretch. Okay, I'm going to go ahead and stop the timer and turn my camera back on. Maybe. There we go. Hi, folks. Welcome back. Good to see you again. So, let's combine the concepts of reducers and context. Hey, Junie Ju. Let's combine the concepts of reducers and context together to tell us how we can scale up our apps using both together. So, as a quick recap, reducers help us consolidate a component's state update logic, right? We bundle it all together into a separate function and we dispatch messages to that function to tell it which action to perform, right? We use dispatchers, send messages to our reducer. The reducer updates the state for us based on whatever action we provide in that message. Then context lets us pass information deep down to other components. So we can combine reducers and context to manage our state. You can kind of see how that might work, right? We'll see some examples of it here. So we're going to learn how to combine a reducer with context, how to avoid passing state and dispatch through props, how to keep context and state logic in separate files, which is particularly useful if you're trying to declutter your code. All right. So first off, we're going to revisit one of the examples that we've already seen. We saw this before, right? Day off in Kyoto. It's a series of tasks, and we can interact with those tasks in various ways. So we can basically do CRUD operations on those tasks, right? We can do add, we're reading it here. We can also do add, update, and delete. Create, update, and delete as well. Our reducer contains all of our state update logic and is at the bottom of the file. That's managing our state for the entire app. Task reducer. Okay? A reducer helps keep event handlers short and concise because each of our event handlers, all they're doing is sending a message out to the reducer. That's all they do. They're couriers, they're messengers. They create the message using a dispatch containing the proper information, and they send it off to the reducer. However, as your app grows, you might run into another difficulty. Currently, the task state and the dispatch function are only available in the top level task app component. To let other components read the same list of tasks, so these tasks right here, or well, whatever's stored in our state, our task state, to let other components read the list of tasks or change it, you have to explicitly pass down the current state and all the event handlers that change it. For example, task app passes a list of tasks in the event handlers to task list. And it once again, we're passing props, right? So the first one here is our list of tasks, whatever that currently is. And the next two are event handlers. We can tell that they're event handlers because they're labeled as such with the on whatever, on change, on delete, on whatever. Those generally, that particular syntax generally indicates it's an event handler prop, and it will be used as such in wherever we're passing it. And then task list. So we've passed these things to task list. Task list passes the event handlers down to task. So that's okay for a small example like this, right? We've got a little bit of a chain reaction going. We're prop drilling a little bit. But if you have tens or hundreds of components in the middle, passing down all of the state and functions can be quite frustrating. This is why you might want to put both the task's state and the dispatch function into context so you can beam them down to whatever location you want to go to. This way, any component below task app in the tree can read the tasks and dispatch actions without repetitive prop drilling. So we talked about this before. We create context, we put state and dispatch into context, and then we use the context anywhere in the tree. So they actually reverse the steps there a little bit, which I think is funny, but that's all right. It all works in the end, right? First thing we always do is create our context, and then we decide what needs to go into our context. In this case, it's state and dispatch. So we create our context first. And we already have our reducer. But in order to pass them down the tree, we'll need to create our context. So we're going to take that reducer and we're going to put it into context. In order to pass them down the tree, we're going to create two separate contexts. The first one is tasks context. That's really hard to say. I don't know if you all know how hard that is to say. I can hardly get it out. Tasks context provides the current list of tasks, and tasks dispatch context provides the function that lets components dispatch actions. So one is a list, the other is a function. All right, and we're going to export both of those. We're going to start with null values for default for both contexts, and the actual values will be provided by the component itself. So as long as we give it some value or something initial, in this case, we're just going to use null, we know it's going to be updated later on by the component itself. So that is valid. All right, now we've created our context so we can load our state and our dispatch into it. So the first thing we're going to do is take tasks and dispatch, which are returned by the reducer, and make them available to the entire tree. So we already have our reducer, and we're going to wrap our entire app tree. So this is kind of what we were talking about before, right? Like what level do we do this at, right? Well, in this case, we're putting them in the top component and we're wrapping everything underneath in both contexts. So we have two contexts going on. We're wrapping the entire task app in both contexts. So anything below it can use them. All right, we can see that, let's see here, in our app.js, at the return statement, our top level component is passing everything down to everything below it. Now we don't need to pass the list of tasks or the event handlers down the tree at all. So we don't need to pass any props into our add task or task list components. Before we were passing in all the event handlers, the list of tasks, all these things, right? We were passing them down. Now we don't need to do that anymore because the individual component that needs them can just call context and grab them. Any component that needs the task list can read it from our context. Const task equals use context text tasks context. That is impossible to say. And then to update the task list, any component can read the dispatch function from context and call it. So down here, we have dispatch. and we're passing it down. We read it, and then we can call it anywhere we want. You says text context. Yeah, no, this right tasks context. I'm sorry, I'm having trouble saying it. It's not working well with my vocal cords apparently. I could never be a rapper. I'm yeah, I don't have the lingual dexterity for that. Somebody get Eminem in the house. I need him to help me read this. But anyway, all we're doing is we're calling context wherever we need either one of those items, either the task list or the dispatch function itself. We just broadcast it across the entire app, and anywhere we need it, we just call use context and pull it down. So we tune our radio to the station and pick it up wherever we need it. News anchor Ron Burgundy. The skeleton was taking a shower. The Human Torch was denied a bank loan. All right, so once again, the task app component does not pass any event handlers down, and the task list does not pass any event handlers to the task component either. Each component reads the context that it needs directly. So let's see how that looks. All right. So we've declared our context for the task list and for the dispatch function. That was step one. The next thing that we did was we put tasks and dispatch into a reducer, and then we provided that information to everything, all the components below it in the app. We've set up our radio station and we're broadcasting that information out and saying, hey, anybody that needs this can use it. So now we no longer need to pass any props. And all the way down at the bottom, somewhere. Oh, I think in let's look at add task. Yeah, in add task, we can see that it's set up to use context, grab the dispatch function, and then call it. So that's an example. So the next thing we can do, now that we've kind of consolidated things down and reduced things, as it were, we've done two things. We've reduced them and we've provided context. We could also declutter our components even more by moving both the reducer and the context into a single file. So our tasks content.js contains only our two declarations at the moment. It's very small, maybe not necessary. What we could do instead is move the reducer into that file as well. Then finally, we'll declare a new tasks provider component in the same file, which will tie all the pieces together. We'll manage our state with a reducer. We'll provide the contexts. And we'll take children as a prop so we can pass JSX into it. So this new component will look like this. Tasks provider takes in the children prop. That's important. If we recall, what children essentially does is just says, hey, this component will wrap around whatever you put into it. So it's basically like we're making a pita pocket. So we have an empty pita pocket. And you could put whatever you want, or taco shell, I don't know, whatever your favorite dinner item is. Can you tell I'm hungry? Whatever your favorite dinner wrap might be, whether it's a sub sandwich bread, pita pocket, taco shell, I don't know, Tostino's pizza roll. We are making the bread for that. This component is the bread, and children is whatever filling we want to put inside of that pita pocket, right? Maybe we're making a gyro and it's, lamb and, I don't know, tzatziki sauce or whatever you put in a gyro. I don't know. I'm a vegetarian. I have no idea. Um, or, inside of our taco, maybe we've got lettuce and tomato and ground beef, or um, pork, or seasoned tofu. It doesn't care what the fillings are. It's just a taco shell or a pita pocket. It doesn't care what goes in it. It's just there to put stuff in. That's what this children pop does for us. So we're building the wrapper, and then we can put stuff inside of it. Is children a keyword? It is. Yes. Children is a very specific prop. It is a keyword. It's named that way specifically to indicate that this tag has content, and the component, when we call the component task provider, we should also display whatever when we reference the component, we're going to put something in there. And so that component should not only display the wrapper, but also whatever is inside of it. So we'll see that when we call it. I'll show you how that looks. And so what we're doing here is we've created essentially a wrapper that already provides context for us in the declaration. We've set up our reducer already. And so now when we call the component, look at this. It just looks like this. I wish I could highlight multiple things here at the same time. But you can see the open tag and the closing tag. This is our pita pocket or our sandwich bread, whatever. Task provider, open, close. It's the wrapper. And then by default, it's going to display whatever we put inside of those open and closing tags. It's going to display the filling. And this is our filling. Day off in Kyoto, add task component, and task list. And since when we declared the component, we also declared the reducer and the context providers, that's implied when we call the component. Now, our context is already being broadcasted to all of these children. The H1, add task, and task list. So that is so clean, right? It's now 1, 2, 3, 4, 5, 6, 7. 7 lines. Well, 8, 9, whatever. But everything else is neatly hidden away in these other files. Now our app.js is so clean, which is kind of what you want, right? App.js should be your top level. Everything else should be referenced underneath that. Code for Dopamine says, I see, so it takes anything within the tag. Yeah, absolutely. That's considered, all this here, H1, add task, task list, that's considered children, and it's passed into the task provider component as a prop. All this stuff is bundled together, crunched down into a prop, and passed into the component itself, right? And then referenced down here. So we're just telling React where to put it, because it looks visually obvious to us that all these things belong inside this component, right? Like that's apparent. But to React, it needs to be spelled out. All right, prop passed in goes here. And we can even, export the functions that use the context to be even more, clean with our code. We could export the use context itself and then call those things, separately elsewhere. Now, and then once we've done that, all the context and reducer wiring is in our context file. So all of the context, reducer, anything related to that, whether we're declaring it or using it, all of that has been bundled up inside of task content. This keeps our components clean and uncluttered and focused on what they display rather than where they get their information. Yeah, so Code for Dopamine, let's look at Code for Dopamine asks, can you explain a little bit more about task dispatch context.provider? Yep. So that is, there's three steps to setting up context. The first one is initializing the context. That's step 1. Step 2 is preparing the components that need it to use the context, right? Setting them up with use context instead of waiting for props, they use context. So they're listening for it now. And then step 3 is providing the context to those children. So basically what we do is we figure out what we want to broadcast on our radio show. Step 2 is giving the people in the town radios so that they can listen. And step 3 is setting up the radio tower to broadcast the radio signal over the range that needs to hear it, right? Finding the right location for that radio tower. And so that's what the provider is. The provider is our radio tower that's broadcasting that signal. So in this case, our provider is broadcasting that radio signal all the way down to all the components beneath it. That provider keyword, the dot provider, that's just a React keyword. We didn't declare that anywhere or anything like that. We didn't. It's not an object that we're passing in. Yeah, it just comes with it comes with context. So if you can see up here, we're importing context. We're importing context up here, and so we can access the provider. Okay, hopefully that answers your question. Hey, Devin Ramsey, how's it going? Welcome to the stream. Oh, thank you for the follow. We're talking about React and using reducers and context. Okay, so any questions on that? And then now that we've kind of like consolidated things, no, it's all good, Code for Dopamine. Don't worry about it. Yeah, it comes from context itself. Exactly. Yep. When we imported context, we can use the provider as well. So now that we've kind of broken things out into their individual files, we can think of our task provider component as a part of the screen that knows how to deal with tasks, right? That's where all the logic is, the big brain stuff. Use tasks as a way to read them, and dispatch as a way to update them from any component in the tree. I'm doing well, Devin. Thank you. So functions like use tasks and dispatch are called custom hooks. So we just made our own hooks if you did that. Your function is considered a custom hook if its name starts with use. Now we've talked about use state, use context. Those things are all built-in hooks, right? But you can make your own hooks if you want to. This lets us use other hooks like use context inside of it. So as the app grows, you may have many context reducer pairs like this. And that makes sense, right? As your app grows, you're probably going to be dealing with multiple concurrent pieces of state. And you're probably also going to be dealing with really deep branching component trees. And you're going to want to deliver that state deep down into those trees. And so what better way to do it than by bundling that state up into a reducer and then beaming it down wherever it needs to go using context. So this is a powerful way to scale your app and lift state up, right? Bringing it up to the top level and then beaming it down as needed throughout the app. This is a powerful way to scale our app and lift state up without too much work whenever you want to access data deep in the tree. So once again, real quick, how we did this. You can combine reducer with context to let any component read and update the state above it. To provide state and the dispatch function to components below, you create two contexts, one for the state and one for the dispatch. Provide both contexts from the component that uses the reducer. So we set up our context in the same place where the reducer lives because we want to dispatch messages back up to it. Use either context from components that need to read them. So any component that needs a certain context or a dispatch can read it because it's being broadcast across the entire app. And then after we do that, you can move all the wiring, all the messaging stuff into one file. You can have many context reducer pairs in your app because you're probably going to be dealing with multiple pieces of state, multiple levels of context, that sort of thing. Whew, that was a lot, but I'm really glad we got through it. Um, I wanted to, really wanted to do all three sections together. So I'm really glad we got through all three. Um, Questions before I talk about where we're heading next? Any questions before? And you're not, and it's okay if you don't understand this stuff right now. That's perfectly valid and fine. What I would suggest is, going back, doing the examples, um, especially for context. I think out of the two, if you're only going to, focus on one of them, I would say that context is probably the more widely useful of the two things we talked about today. But using them together could be so powerful. If you can bundle your state up into a nice little compact signal and then broadcast that signal wherever it's needed to any component wherever it lives. I don't know. I think that's like a really powerful combination of concepts. However, does that mean that you have to use it? No, absolutely not. Like we talked about, you can build stuff with just use state if you want, right? You never have to use context. You never have to use a reducer, but you can. And if you know how, you can probably build much cleaner, um, better organized apps. Okay, I'm not seeing any questions, but that doesn't mean you can't ask. Feel free to ask if you want to know anything, or have questions about what we covered today. So, where are we heading next? That's something I've kind of thought about. There is one more section. However, this section is about what we call escape hatches, and a lot of that is about how do we. Feel free to ask, Devin. Yeah, go ahead and ask. Um, how do we connect React to outside um, systems and things, APIs, like they say here, APIs, video players, remote servers, that kind of thing. I think I don't want to cover that yet. I think what I want to do is take what we've learned, all these concepts that we've learned in the first three sections here in UI, interactivity, state, all these things, props, components, um, state, updating state, use state, the hooks that we've learned, and build something with that. So like actually go back to project building and build something with that, and then implement things from this last section if and when we need them. I think it would be superfluous to cover all of these things. Um, Especially given that they're considered advanced, and I don't want to overwhelm. Right? We've covered a lot, and y'all have stuck with me through, through these first three sections. I feel like we're more than ready to build something out of what we've learned, and I think it might be worth it to do that, and then revisit some of these more advanced topics later on, if and when we need them. Ah, Drunk Uncle Grandma says, WebDev Simplified has a front end React e commerce tutorial using use context for each shopping cart item. Oh, rad. No style.css. Yeah, yeah. He uses Bootstrap, uses UseEffect for local storage, and makes his own hook called Use Local Storage. I will check that out. Drunk Uncle Grandma, if you have the link to that, if you want to ping me with it on whatever platform you want to ping me with, I don't care. Um, Oh, thank you. Yeah, I will. I'll grab that and check it out. Code for Dopamine says with back end and off. There sounds like I heard that in Bender's quote. I'm gonna build my own web app with back end and off. Yeah, but yeah, it's gonna be a full stack. Whatever we build is gonna be full stack. Um, I don't know what it's gonna be yet, but we'll figure something out. I think it's time to build something. It's been a long time since we've built something here on stream, and that used to be what we did primarily before, until we started going over these docs. So I want to get back to build something. If anybody has suggestions, like Drunk Uncle Grandma just provided there, feel free to send them to me here on Twitch, on Discord, whatever, wherever you want to. Topic or things to build, preferably with React. I want to apply what we've learned and walk through that together. So, uh, but yeah, I'm always open to suggestions. Um, and third decade, I apologize. I just realized that I never did your poll. Can I give you a rain check on that, and we'll do your poll in next week in my next stream? I hope that's okay. Third decade, I apologize. I never set up your poll. Sorry, but I can set it. I can give you a rain check. You won't have to spend your points again, and the poll can be whatever you want next time. If you want the same topic, you can do that, or a different topic next time. No points required. Just remind me, okay? Oh my goodness. Dr. Moto just redeemed a channel port reward that I have never, no one's ever redeemed that one, at least not yet. So Dr. Moto redeemed Next One's on You, which allows Dr. Moto to pick the um, the topic of whatever the next stream that we do is. So Dr. Moto wants me to play Vim Tutor. It's going to take me too long for me to name a cat Goku. Okay, Vim Tutor. All right. Yeah, we can do that for the next stream. Whatever Vim Tutor is, I will have to look it up. And I guess that'll give me more time to figure out what React app I want to build with y'all. So we'll take a brief detour into left field, play Vim Tutor next time, and then get back to building a React app. Again, please, if you have suggestions on what you'd like to see me build with React and apply the things that we've learned, then send me your suggestions. Drunk Local Grandma, I will check out that tutorial that you sent. Absolutely. And Devin asked, Mayan Wolf, what is a web developer? And what you're doing? Are you like developing websites or programs or something? Yeah, Devin, that's a great question. So, web developers, I mean, it's kind of a web developers can do a lot of things. Of course, a big part of it is building websites. Any website that you visit was built by a web developer at some point. Um, and so developers can build websites, but they can also do other things. So they can also build the APIs, so the things that give websites their data, right? Websites have to get data from somewhere, right? And so sometimes that data is provided by an API. And websites can connect to that API and have it deliver them data. Uh, Web developers can also work with databases because sometimes you might want to store data from the people that visit a website. If I go to a website and I create an account, I sign up, right? I click that sign up button and I put in my username and I put in maybe my first name and my last name and my state that I live in and my phone number and a password. And I click save and I create that account. The next time I go to the website, I expect that if I log in, it's going to remember me, right? But you may not have thought about this before. That data about you has to be stored somewhere, right? It has to be remembered. How does the website remember it? And a lot of the times that data is stored in what we call a database, which is, a big warehouse for data. And so web developers often have to know how to work with databases as well. So it's more than just websites. It's what you see on your screen and then everything behind it, all the gears and the wires and things that make that website run and show you the things that you see on your screen. So web developers can do a lot of things, and I hope that helps answer your question, Devin. um, a lot of what I do on this stream is related to building apps rather than websites. So by apps, what we mean is, it has a user facing appearance, right? The thing that you see on your screen. And then it also has all the gears and things that create and store the data that's displayed on the screen. But web developers can be what we call front end developers, which is where they just make the things that users see. Um, or maybe they can be back end developers where they don't ever make things that users see and they work with the databases and the APIs and the things that power those websites, or they can do both. Um, so yeah, there's a lot of options there with being a web developer. Dr. Moto says, not if it's my website. Talked about storing data. Yeah, not every website has to store data, right? Sometimes websites can just be a place where you have your restaurant, and it just shows a menu in plain text, an address and a phone number, and that's fine too. Websites don't have to be complex. Sometimes good design sometimes good design is not complex. Sometimes good design is simple and readable and accessible to everybody. That's how my my websites don't tend to have a lot of style. But yeah, my day job though, what I actually get paid for, is not web development. I'm a back end developer, working with enterprise scale databases. Nothing to do with websites at all. I work with databases using SQL, or structured query language, which is a database language. However, I think web development is fun, so that's what I do in my free time. I don't get paid for it though. Oh, good. Okay. Yeah. Yeah. Mainly what I do on my stream is web development related stuff because I think it's fun. Um, Not my day job, but it's always fun to learn things that are different than what you do for your day job, right? When I come home, I sure as heck don't want to do more SQL, even though I love SQL. Yeah, exactly. Variety is the spice of life, right? And Devin, if you want to learn how to be a web developer, um, you can do it for free. You should never have to, don't pay for a boot camp, okay? If you're interested in web development, don't pay. We have a very active, it's not my Discord, but it's the group I'm a part of called 100 Devs. We have an extremely active Discord. All the classes are free. Um, and I mean that like for real. Never paying anything. Everything is free. All the lessons are free. You can go from zero to web developer if you want to, and then get a job. Um, just don't ever drop 10 grand on a boot camp. Uh, you can learn all the skills that you need for free, on through 100 devs, or there's all sorts of online resources out there. Yeah, here I'll give you I'll give you the website and the Discord, and you can check it out for yourself. Again, don't take my word for it. Check it out yourself. Let me do that here for you. Okay, so in chat we've got the website for 100 devs, the Twitch channel, which actually not streaming right now, but the Discord is probably the one you'll want. It's very active. So check out the website for a good summary, and then check out the Discord to see how the community is actually what the community is actually like. And then there you'll find links to all the lessons. Um, Whatever you want to do, if you want to talk to other people in the Discord and get their experience with 100 devs, if you decide you want to try it out. But yeah, ask around, see what they think. It's like, what was it, on Reading Rainbow? Didn't LeVar Burton used to say, like, don't take my word for it, read a book or something. Don't take my word for it, read the Discord if you want. All right. Okay. Sure thing. You can also click. You should. Devin, you should also be able to click on those links directly, and then it'll open it in a new tab for you, if you want to save them that way. If you don't want to have to write them down, you should be able to click on it. It'll open it in a new tab, um, and then you can save them that way. Trust but verify. Absolutely. Yep. People are going to say a lot of things online. The best way to do it is to check it out and verify for yourself. Yep. Okay, any last questions before we wrap up? I got to go feed my foster kittens. They are due for a meal, but I'm happy to answer any last questions before we raid somebody and get going here. All right, let's look at a raid target. If anybody has any suggestions, as always, if you have a suggestion of someone you'd like to raid, please do let me know. Otherwise, we're just going to see who is online and hit them up. Okay, where's my raid button? There we go. No worries. I'm glad you enjoyed it today. Like I say, next week, Dr. Moto has declared that we will be playing. I gotta look at what that's called again. Vim something. Oh, Vim Tutor. Okay, we'll be doing that next week, and then after that, we are going to be building a React app from scratch, full stack, front end, server, back end, all those things, and applying everything that we've learned from React so far. It should be a blast. I'm looking forward to it. Um, we'll see, Dr. Moda. I want to honor the channel point redemption. I guess we'll see how far I get, um, with the app I decide to build. Um, yeah, I don't know. We'll see. It'll be a surprise. Next week, be prepare to be surprised with whatever I decide to do. I usually don't plan that far in advance. So we'll see. All right. As far as raiding, I'm seeing that Vash is online. If y'all are interested in that, we can raid them. I haven't seen any suggestions, so I think we'll go ahead and raid Team Vash. All right. I hope everybody has an excellent week. I'm starting the raid now, and I will see you all next Sunday for whatever I decide to do. Next Sunday, 3 p.m. Eastern. Tune in for whatever the heck is going to happen. All right. Oh, oh wow. Devin, sorry, I just saw your message. I'm on a PlayStation 4. Oh goodness. Yeah, web browser is not good on PlayStation 4. I am well aware of that. No worries, Devin. I hope to see you back here next week. All right. Bye, all. Have a good week. Oops, I accidentally canceled the raid. Sorry. Try again. One more time. Yeah, I screwed up. All right, should go now. Okay, bye, y'all.